Good morning. Welcome to the Jet Propulsion Laboratory. I'm Cinzia Zufada, the Associate Chief Scientist. We are thrilled by the presence of so many college students with us today to celebrate Women's History Month. Across the NASA family, events are taking place to recognize the key role women are playing in the success of our nation's space program. And all over the world, Women's Day, International Women's Day, is being celebrated. Today, you will hear from women leaders in science and engineering who want to share a bit of their stories and also want to hear from you. And now, to tell you about who we are, let me invite the director of the laboratory, Dr. Charles Elachi, to the podium.
Thank you, Cinzia, and I want to welcome all of you to JPL on this great event to talk about the history of women in science. I need to tell you from the beginning, I'm biased. Matter of fact, I'm very biased on this topic because I have two daughters. I think they are the smartest human being in the world. Even sometimes I see them walking on water. So I'm a little bit biased on this topic. Matter of fact, I know they are smarter even than their dad. I want to tell you a little anecdote. About 4 or 5 years ago, when our younger daughter was in college, we bought one of these very sophisticated TV, DVD, CD, electronic, and she was at home. So, of course, I opened the manual trying to figure out how to put it together. She didn't even look at the manual. She helped me. She put it all together, and then she went back to college. And the following day, I was trying to turn on and watch something, and I couldn't figure it out. I looked at the guide, I couldn't figure it out. So I picked the phone and called Lauren and said, Lauren, how do you do this? And there was this few second silence, and she said, and Dad, and you run JPL? So that's her nice way of saying she's smarter than me on doing that. Now, no question, we have come a long, long way in the role of women in science. I remember when I was a student at Caltech, that was the first year that women were accepted at Caltech. Today, the freshman class is 44%, are women, at Caltech. When in the early days of JPL in the 60s, even though there were women, their technical role was very limited. The main thing, technical work that the women were doing was we were relying on them to do calculation of trajectories. I guess they were more conscientious about doing proper calculation, than the rest of the lab. Well, today, 30% of our technical staff, are women here at JPL. If we can show the slide that shows you just a montage of some of them that are here. I'm always nervous to show these montages because people will tell me, well, what is my picture, in that one? On the executive council, when I joined the executive council about 15 years ago, there were no women on the executive council or no deputies. Today, we have 5 women, including women who heads all our technical divisions. That's 70% of the lab. So where all the engineers and scientists are in the organization headed by Leslie Livesey. And we have also a woman heading our earth science activity, which is one of the largest, activity here at JPL. And interesting enough, also, we have today a couple of the speakers. Also, in those days, we didn't have many women, or matter of fact, I'm not sure there were any women who were principal investigators, on missions. That means for the people who are not in our field, principal investigator is a person who's really in charge of a mission. So they run that mission scientifically and oversee all the technical implementation. Well, in the last year, we launched 2 PI missions, and we're launching one coming up literally, hopefully this month. Out of those 3, 2 of them, are women principal investigator, and you'll be hearing from them, even that they are, one of them, Maria Zuber, is from MIT, and Fiona Harrison from Caltech, 2 pretty good schools, that we have. But we consider them as honorary members, of JPL. They worked with us for a number of years, to make these missions a success. So as you can see, women have come a long way. There is still a way to go, but women have come a long way. And I think it's very important that all of us, we reach to the young girls in schools and tell them that being in science and engineering is not only fun, but also you can build a great career in doing that, and you can make an impact, in the whole field, at least in exploration and space science, but also across the field. So today you are going to be hearing stories of challenges and accomplishment that women have accomplished here at JPL and have experienced, here at JPL, and the kind of things that they are working on today. And we look forward, at least I look forward, and I know many people look forward, for the impact and the accomplishment and the advancements that women will do in an organization like JPL. And hopefully a few years from now, not too far in the future, when you come here and you are being welcomed by the JPL director, it will be a woman who will be a director of JPL. Thank you very much, and I look forward for the presentation.
So, and now, as we are getting ready for our first panel of speakers, let me say a few more things about participation here. We have over 200 students from many local area schools, universities, colleges who have been invited to be here. And we want to bring you into our family here at JPL, and hopefully make this a good experience for you, a way of sharing what we do, a way of making friends with you. So for our first panel, we have assembled a truly unique group of distinguished women, as Charles has alluded to, who have achieved leadership positions in space missions. Pat Morrison, a journalist with the Los Angeles Times and Southern California Public Radio, has generously lent her time to be here with us today to engage them in a conversation about what they do, what they have overcome.
We're going to be hearing from each of our panelists. I'll be asking them some questions and then taking some questions, of course, from you in the audience. So be thinking of good ones, as I'm sure you will. These ladies have done the vital work of space work. I've covered a few space shuttles from a distance, a safe distance, and that's about the extent of it. I was watching a public access channel today, which is to tell you how basic my basic cable is. And there was a high school science quiz competition for Los Angeles, and it was the finals. And there were 2 teams, 4 members each, and not a one of those 8 was female. Now, if you step up to post-K through 12 education, more than half of the students enrolled at many colleges and universities are women, but in the sciences, enrollment is a fraction of that. And in academic positions, you find even fewer. My friend Frances Arnold is doing stupendous things at Caltech. Of course, Sandra Singh Low is doing great science on the radio. My sister-in-law teaches physics. My niece went to MIT. I left a couple of seconds there for all the Caltech people to boo if they wanted to. But see, I'm running out of women before I'm running out of fingers, and that's a bit of a problem in our society. Women make up half the workforce overall, but in science, technology, and engineering, they're barely 25%. Why is that the case? Is it scientific illiteracy? We certainly have that. Neil deGrasse Tyson was telling me the other day that about 1 in 5 Americans still believes that the sun revolves around the earth. Is it cultural pressure? Some of you won't remember this because you weren't even born then, but 20 years ago, Teen Talk Barbie doll said things like, party dresses are fun, and math class is tough. Well, there was an outcry from women's groups, and Mattel recalled the math challenge Barbie, but that sensibility is still out there. If you were to ask the average American to name one woman scientist, he would probably name Marie Curie. If you asked the average American to name 2 women scientists, he would probably be stumped. He might name the Amy character on The Big Bang Theory. Or he might know Rosalind Franklin, who was the woman who died before she could be considered for her work on the structure of DNA for a Nobel Prize. Could have Carolyn Herschel, who was half of the brother and sister astronomer team. Now, I have a couple of favorites. You'll find out why in a second. Nancy Johnson of Philadelphia. About 150 years ago, she got a patent for the first ice cream freezer. Yes. And a young British food chemist named Margaret Roberts was in on the creation of the soft serve ice cream. You may know her better by the name in her other career, Margaret Thatcher. As for women in space, well, some people would say the first one was Alice Cramden on the TV show The Honeymooners, because her bus driver husband kept threatening to sock her and send her to the moon, Alice. But there have been still so few women in space that if I were asked the question on Jeopardy, of course that isn't a question, they'd say, first woman in space, I'd say, Alex, who is Valentina Tereshkova? One of those pieces of information that you keep in your head because there are so few. But women in space science are what we're hearing about today. These women up here have overcome myriad obstacles to make it to the top of their disciplines, and how they did it, you're going to hear from them. The first is Margaret Kivelson, PhD in theoretical physics in the 1950s, professor of space physics at UCLA, team leader on 2 Pioneer missions for Jupiter. The rest she's going to tell you herself.
Thank you. So today I'm talking about working in a man's world, because that's where I started, at a time when space science didn't exist, so I did not do my PhD in space physics. But that's a nice thing about physics, is that once you learn it, you can use it for space or ice cream makers. Next. Anyhow, my first message is that if you get yourself in an environment where it's mostly men, pretend not to notice. Next. But today, the point is to notice, so we're going to start with that. Next. So when I started in physics at Harvard, it was immediately after World War II, and physics was quite glamorous. I think perhaps it was the most glamorous state that it held in my lifetime. And I decided I want to be a physicist. I started in my freshman year in a class with 10 women and 400 men. I then went on for a PhD, and roughly 1 woman in every class of about 60 PhD graduate students was a woman. Of the roughly 1 a year who was admitted, roughly 1 got a PhD every other year, and there was always somebody who was dropping out before they completed their degree. So next. The image you see was the celebration of the 60th birthday of my advisor, Julian Schwinger, who was a Nobel laureate. And you notice the significant lack of women. If it hadn't been for me, there would have been none. Next. So what you can see is in this beginning of my career, it went from 1 in 40 undergraduates, 1 in 60 graduate students, 1 in 120 PhDs. Definitely an example of the narrowing pipeline. And Pat has mentioned that. Next. So I've put up some plots to show you the changes in the number of women, and the red curve is engineering, the blue curve near the bottom is physics. And what you can see is that between 1950 and 1998, there was a slow increase up to about 20% of bachelor's degrees. So I'm just talking about bachelor's degrees. I want to call your attention, though, to the second red curve, which is the number of women getting bachelor's degrees in computer sciences. And puzzlingly, it increased very rapidly in the beginning of this period, and then it began to decrease, and it wasn't clear what was happening. You can see I was trying to make an extrapolation to 2003 with the physics line there. Next. I finally found the next decade, although there's a gap of a couple of years, and what you can see is that the computer sciences, that's the dashed red curve, flattened and continued down. So it is not always it is not always the case that things keep going up. They can go up and they can go down. They didn't record physics separately, but engineering was recorded separately in this. And what you can see, the flat line near the bottom, is that engineering has remained fairly stable as a bachelor's degree for bachelor's degree candidates. Next. So I've gone through my albums and looked for women in photographs I have of workshops and meetings. And at the top you can see, on the left, you can see me with the Galileo magnetometer team after one meeting, and I think we have 2 women there. Then there's, to the right of that is a turbulence workshop, and again, absence of women. At the bottom is a group photograph of some of my students who came for a celebration, and there is one woman among them. Now, that was about a decade ago, and happily now, I have quite a few women graduate students, so I'm very pleased with the change. Next. I looked for photographs of award ceremonies. Usually there are 1 to 3 women among a lot of tuxedoed men up on the platform. It's still a long way to go before we will find women being honored proportionately to their representation, even in the realm of physics. Next. At UCLA, we've been making a very serious effort to recruit women, and we've done a very good job of recruiting, and we often lose them very quickly thereafter. We're good at identifying people who are going to go places, and they do go. Next. So to end, I wanted to show a few more pictures where you could see the progress in a little area of space physics. These are group photographs taken at some of the roughly biennial meetings on magnetospheres of outer planets. It's an international group, so this is not just women in the US we're looking at, but women from all over the world doing magnetospheres of the outer planets. So next. This is the first image I could find, 1977 in Lindau, Germany. I put a red oval around every face that looked like a woman. And it's not an accident that I'm in most of these photographs. Next, please.
She's skewing the curve, you know.
Yeah, I'm skewing the curve. So here's 1986 in Iowa. I had left already, so you could add one more circle. Next, 88, back to 1. Next one. The meeting at UCLA, we begin to see a sprinkling of, maybe it's because I was running that meeting. Next. So 2005, this is in Leicester, and we see more of the ovals, red ovals. Next. 2007 in San Antonio, Texas, we're seeing even more. Next. 2009, that was in Cologne, Germany, and the next one is last summer at BU. So let's go to the next. I decided to plot the fraction or percentage of women. Next. And it does look as if it's going up. But remember that computer science, next. Maybe it's going down. I don't know. It's not obvious what's happening. Next. So change may be slow.
Well done. I have those shoes.
Next. So small steps may get you nowhere, but maybe they'll get you somewhere. Next. This is one of my favorites. You never can tell who's going to be looking in the right place. That's it. Thank you.
Margaret. You've gone from sitting in the classroom at Radcliffe to teaching in the classroom at UCLA. What's changed in the classroom? Has anything changed?
Well, I think there are a lot of things that have changed. I think students are less polite than they were when I was a student. And there are more women. There are more women. At UCLA, in my department, which is Earth and Space Sciences, a very large fraction of our students, both male and female, are from China. And there we're bringing in a lot of terrific Chinese women. I would love to see more women in my classroom have gone through the American education system. I think there's a worry that we still don't attract women through whatever it is we do in education.
What is it that the women, the American-born women who come into your class tell you about the education they've gotten, the encouragement or the lack of it they've gotten?
I don't hear complaints. I mean, you know, whatever it is that's going on is very subtle. It's women are discouraged in ways that are very hard to identify.
We had the president of Harvard, Larry Summers, get himself in hot water by disparaging the abilities of women in science.
Yeah, and that was a lesson for Larry Summers, but I'm not sure it was a lesson for me.
When you talk about that recruiting is good, but retention is bad, where are these women going, the women who may come in with such enthusiasm?
There are two things two ways in which we lose women. One is they get offers from places that they find more attractive. And there are not many, but there are a few places that can pull women away from UCLA. The Ivy League colleges can, Berkeley, Stanford, Caltech. And the other problem is the two-career family. And we have lost quite a few women because they went somewhere where there were jobs for the woman and her husband.
And whose job consideration led that?
It was usually, I mean, I can't, the statistics are small numbers. So there was one case where a woman went to a lesser university because they would also hire her husband, whom we were unable to hire at UCLA. And there have been other cases where the woman has followed her husband, and her husband was able to encourage the other university to give the woman a job.
It occurs to me that American schools can take Mao Zedong's saying, women hold up half the sky, and turn it into women explore the whole sky. Maybe we can take that and make something out of it. Thank you. Let's hear next from... Let's hear next from Maria Zuber. Let me find out her information here, or she can jump in and tell us herself. Oh, how bad of me not to have this. And of course, we'll be taking your questions at the end here. She's a professor of geophysics at MIT, principal investigator. PI in my world means private investigator, like Humphrey Bogart. PI, very different in this world. The Grail mission measuring the gravitational field of the moon. She's studied the asteroid Ceres and Vesta, and working on the laser altimeter that she created for the Mars Global Surveyor spacecraft to check the topography for any planet, including Earth. I think I've heard of Earth. Thank you so much. Tell us about your work and how you got there and what you had to do to get there.
Okay, thanks. So I'm going to tell you a little bit about the Grail mission, which is just started taking data around the moon in the last week. So if we could have, let's see, the next slide. So that's what you see up there. That's an image of the topography of the moon, which has actually been measured with another instrument that we have that's measuring the moon right now, the Lunar Orbiter Laser Altimeter. And what you see there on, I guess on the left-hand side is the near side of the moon that we see from Earth, and the back is the far side of the moon that we don't see ever from Earth because the moon rotates synchronously. And what you notice is that the near side and the far side of the moon are different. And we don't know why. And what's very interesting is that collectively, the nations of Earth have sent 109 spacecraft to the moon. orbit the moon, to land on the moon, bring back samples, and we don't know why the near side of the moon is different than the far side of the moon. So it occurred to me that the answer is not on the surface, because if the answer was on the surface, we would have known it by now, because the previous missions have focused on the surface. So if you go to the next slide there, we decided to take a dedicated mission to measure the gravity field of the moon, to study the mass distribution of the lunar interior, that we could use this information in concert with the information from those other 109 spacecraft that have been to the moon and are at the moon now, and put together a holistic picture of what the moon is like and how it evolved. And we got together. There was a group of us. If you study the physics of the planets, the gravity field of the moon is it's one of these. It's a trophy that you want to have on your mantelpiece. Okay, and so for decades, some of us have wanted to do this, but to measure gravity, you have to measure very tiny changes in the frequency of radio signals, and you need to track those from Earth. And the problem with the moon is you never see the backside. Okay, so lunar gravity has been interesting since the initial spacecraft went to the moon. The lunar mascons, they were worried about being able to land astronauts safely in the moon because of how the spacecraft would bump around due to the lumpiness of the lunar gravity field. And so for 40 years, this has been, what I'll call a low-hanging apple on the tree that we have not been able to grasp. But technology came to our aid, because the way that you measure gravity on the backside of the moon, if you don't track it, is you take two spacecraft and you let them make measurements to each other. And so our mission is all about taking radio signals and having the two spacecraft track each other, then tracking them from Earth. And there was a mission called GRACE that's in orbit around Earth right now. And the instrumentation was built here at the Jet Propulsion Laboratory. And so the demonstration of that technology is what allowed us to finally propose this mission to the moon. So in the next slide, if we look at that, this is some pictures of the hardware. So there's the two spacecraft. When you work in this business, I'm a parent, and I think of the spacecraft and the instruments that I built almost as my children, okay? And so I got these two guys that are in orbit right now. There's a terrible solar storm, and it's like when you're a parent and you send your kids off to school and you wonder, oh my God, I didn't know it was going to rain today. And so they're essentially up there with their sunglasses on, waiting for the solar shocks to pass through. But there's the hardware, and there's the instrumentation. And what I wanted to point out by this is just if you're thinking about a field like this, working on a team and also making an individual contribution, this is really a wonderful field to be in. Because if you look at all those little pieces of hardware up there, everybody involved in working on every aspect of those has to do their job perfectly, or else this mission is going to fail. So everybody on the whole team has an extremely important job, and there is a great deal of mutual concern and mutual respect for the work that everybody does. So one of the things that from psychologically looking at the literature is that women tend to be more social and like to work in groups. And so one of the things that I've just really enjoyed about working on space instruments and space missions is getting together with a wonderful, smart, dedicated group of like-minded people and creating something much bigger than I myself or any of my colleagues can do in isolation. And I think this just illustrates that. So that
where, if I can ask you, is
Yeah.
that an advantage and where is it a disadvantage?
where is it?
That sense of the teamwork that
Well,
that
it's
women put an emphasis
you know,
on.
on the team, everybody shares the credit. Okay, so if you are a person who likes to or needs to get all of the attention, that doesn't happen on space missions because everybody needs to share credit. Okay, and I think that's a wonderful thing because when one succeeds, there's plenty of credit to go around, so everyone can have credit. But you know, it's not the right thing to do if you want to call all the shots yourself. You can't know enough. Nobody can know enough to do all of this work on their own. So, okay, all right. The next chart. We did a lot. I have just a wonderful, wonderful, smart group of people that I work with on this mission, and they just came up with so many clever ideas, and sitting around and brainstorming how you can do things clever, and sometimes clever can mean inexpensive. But of course, you don't want to be too inexpensive because it doesn't work. It doesn't matter how much it costs or doesn't cost. And if you notice with those two spacecraft, they're pretty small. Actually, they're about the size of, I like to say they're about the size of a apartment-sized washer and dryer. Okay, and we made them small so that they could both fit on one rocket. So we actually, by making them small instead of big, we saved $150 million because we could use one rocket instead of two rockets. And one of the main ways that we were able to use small spacecraft is that we took a very innovative trajectory to the moon. And so, you know, the Apollo astronauts got to the moon in 3 days, okay? And so you can do this, you know, you send a rocket to the moon, and you go barreling towards the moon, and in order to get into orbit around a planet, what you've basically got to do is slow down enough for the gravity field of the planet to capture the spacecraft, okay? So if you go shooting towards the moon, you got to really hit the brakes in order for the lunar gravity field to capture you, okay? So we, instead of going towards the moon, we went towards the sun, okay? And that's a picture of the trajectory up there. We didn't go to the moon in 3 days. We went in 3.5 months. But when it's what's called a low-energy trajectory, and we use something called the Earth-Sun Lagrange point, which is essentially the place where gravity balances between the Earth and the sun, and essentially use that point as a buoy to go around. And so but when we got to the moon, when the two spacecraft got to the moon, we only had to slow down by 170 meters per second to get into orbit. So we were able to use very small fuel tanks. And so this was just another clever thing that the team thought of to do this.
It sounds like a good analogy for a career trajectory, too, because once you get up to a certain level, it's pretty easy to get that last little bit because the gravity may be helping you out. But to get that far, as a woman, to get to the point that you have, I mean, that's where the energy comes in.
That's actually a really good point because I think in general, for a woman early in a career, it's maybe a little bit more difficult to get noticed. Okay, but once you get over that gravitational well, so to speak, because there are fewer, you get noticed.
Good noticed or bad noticed?
Well, you know, at some point, you know, you've got to stand on your own because of your work. So once you get to the point where you're established scientifically, I think you can be judged more easily on the quality of your work.
Do you agree with Margaret that once you get in a work circumstance or even a class that's all men, you just have to pretend not to notice?
Well, I never did notice, okay? That's, somebody told me this once, and it was actually a great piece of advice. Ignorance can be an enabler, and I was usually the only woman in class, and I just most of the time would never notice. And in fact, when I was on my first space mission, it was a mission called Mars Observer, I got a phone call from a reporter that said, you know, there are 87 science investigators on this mission, and you're the only woman. And I said, no way. and after I hung up, I pulled out the list and started going through it and went, oh, wow, you know. So it was true, and I had never noticed.
Then it became a strength, I would think.
You know, now when there are conferences, you know, in a lot of cases there are attempts that are made to have some balance and, you know, make sure that you invite women. So if you're the only woman out of 87 investigators, you get asked to speak in public a lot. So.
Thanks very much.
So, yeah.
Amy Manzer is a research scientist here at JPL, principal investigator of the NEO-WISE project, which is an outgrowth of the project she conceived to enhance the ability to find new near-Earth asteroids. If she doesn't have a Hollywood agent for that kind of line of work, you really should. She says the universe is weirder, a more wonderful place than any science fiction I've ever read, but I'm sure that she'll have some good ones coming up for us.
Well, thanks a lot. So if we could take a look at the next slide, we will get started. And so basically what we did is with the WISE mission, this is the Wide Field Infrared Survey Explorer project. And the goal of this project, oops, got a bad mic, sorry, hope you can hear me. The goal of this project that I worked on was to survey the entire sky in infrared light in 1 year. So it was really a whirlwind trip. I have to say it was a phenomenal experience to get to do this. And one of the things that we got to do is find a lot of asteroids. And that was a kind of an unexpected bonus to this project. So if we could have the next slide. I'll tell you a little bit about infrared light and why astronomers would care about it. I mean, you would think, well, isn't the visible light that my eyes see good enough? And it turns out that your eyes only see a tiny, tiny fraction of the whole electromagnetic spectrum of light that's actually out there. So astronomers sometimes use other wavelengths like infrared, ultraviolet, X-ray, and in particular, with infrared, you've got certain benefits. You can see these pictures of coffee cups there that I'm holding, 2 identical coffee cups, and to your eyes, which are sensing the visible light that's reflected off of the coffee cups, they look exactly the same. You can't really tell anything about the contents of what's inside these cups. But if you have an infrared sensor that's capable of measuring heat, you can very clearly see which coffee cup has the hot water and which one has ice water. And you can also see that my nose is cold in that picture. So it gives you an idea of what the utility is of these other wavelengths. And in particular, when we use them to look at, say, for example, asteroids, they're very good at telling the temperature of these objects. And from that, we can learn physical characteristics such as their diameters, how big they are, and get a little bit of a glimmer about what they're made out of. So if we could have the next slide, please. Okay, so let me tell you a little bit about the telescope that we used. Like I said, it's the Wide Field Infrared Survey Explorer. And it was a small telescope. It would sort of fit under your arm. It's about 40 centimeters. It launched in late 2009 out of California, Vandenberg. And it was hundreds of times more sensitive than the predecessor satellites. So one of the main things that we did is we came up with a little enhancement to the WISE data processing pipeline, and we call it NEO-WISE, which stands for Near Earth Object plus WISE. And in NASA, we love our acronyms, so I get double points because it's 2 acronyms in one, which is really kind of cool. But if we have the next slide, I can show you a little bit about what WISE was all about. So the goal of the mission was to survey the whole sky, like I said, in just 6 months. And the way we did that is by taking a picture with a 4-megapixel infrared camera every 11 seconds for an entire year. So you can imagine if you sat there taking pictures every 11 seconds for a year, it would build up quite a lot of data and quite a lot of images. And you can see there an example of how we were able to cover the sky so very quickly. Okay, let's have the next slide. And there's a picture of WISE. And I think it's like Maria said. I mean, these things do become your babies in a way, and there it is, all packed up and ready to go just
You get
before
to paint
launch.
a slogan on the nose cone the way they did World War II bombers?
Unfortunately, no. But you do get to take some pretty cool pictures with it, which is good. So that's fun. But yeah, unfortunately, painting slogans on it would probably be bad for getting to space. Unfortunately, probably have some bad side effect. So you can see it there in the rocket, in the nose cone, and that's a picture of the spacecraft there sitting in the high bay just before it was packed into the rocket. And if you have the next slide. So this is our previous picture of the whole sky in infrared light from a mission that was launched in the mid-'80s, and it's one of the instruments on board. Another acronym is called DIRBE, Diffuse Infrared Background Explorer, I think. And there's a picture of the full moon just to give you a sense of the scale. So this is what our best view of the sky at these wavelengths was like in the past. Now if we have the next slide there, okay, again. Okay, so now if we go to slightly longer infrared wavelengths, this is another mission called the Infrared Astronomical Satellite, and it was launched in 1983. It had 62 pixels on board its digital camera. And so with WISE, we have 4 million. So we were able to bring a lot of new technology to bear on this. And you can definitely see that there's a star there in this image, but it's still very pixelated and rather crude. If you have the next slide. This is the view of the same part of the sky from WISE. And this was our first light image, which we managed to take on New Year's Day, or New Year's Eve, actually, about a couple of years ago now. So that was a great New Year's present, and it was a lot of fun. So if we have the next slide. Okay, so moving on, this is one of my favorite pictures from the mission, and it just illustrates what WISE was all about. An all-sky survey in 4 infrared wavelengths. Beautiful nebula there, beautiful, beautiful star-forming region, but there are some little dots, and if we have the next slide, you can see I've highlighted them there. Those are asteroids, those little dots. And what we did with the NEOWISE project is come up with a way of finding these little dots automatically with computers, instead of having to go through these millions of images by hand, which would have been absolutely impossible. So the pipeline automatically found these objects, even though they're in the middle of this huge cloud. And so let's go on to the next slide. Now, I've talked a little bit about what infrared is good for, taking temperatures. And I've mentioned that it's good for measuring sizes of asteroids. And if what you care about is the frequency with which they impact the Earth, this is a good thing to know. So this graphic here just gives you an idea. With visible light, it's very hard to tell the difference between an object that's small but very shiny and reflective, and an object that's very large but dark, like a piece of charcoal.
It's like TSA, in other words.
Yes, it's
Okay.
kind of a special sensor for figuring out what's really going on there. Because when we see asteroids far away, they just look like dots. Most of the time, we don't have beautiful up-close images like what Carol is going to show you. So when we see them from far away, they look like dots. And into a visible light telescope, it's very hard to tell the size.
So you have to infer a lot.
That's right. And with the infrared telescope, you can get a much more direct measurement of how big the object is, and that's important. Also, too, we tend not to miss the smaller, darker objects that are out there. So if we have the next slide. Okay, so go ahead and click on the movie there. And we will give you, it's a top-down view of the solar system as it was observed by our spacecraft. And let's give it there you go. Okay, so that is the orbit of Jupiter. Is that working? Oops, looks like we may have a technical failure. Okay, well, I'm just going to go ahead and talk about it. So what you would have seen there is basically lots and lots of dots. And each one was an asteroid that was observed by the project, by NEOWISE. In total, we observed something like 158,000 asteroids, and we're still digging them out of the data as we speak. And we found a bunch of them that actually get close to the Earth, and these are the near-Earth objects. So what we've been able to do is use our sample from WISE and from NEOWISE to extrapolate how many are out there in total and how big they are, and also learn something about their orbits, which for purposes of calculating the actual impact frequency to Earth, these are things we need to know. Okay, so let's just ditch the movie and move on. All right, so one of the things we were able to find is that we've actually done a pretty good job. The whole worldwide community of both amateur and professional astronomers has actually cleaned up pretty nicely on the really big asteroids, the really big near-Earth objects. These are sort of the planet buster size things, the things that are thought to have been responsible for the extinction of the dinosaurs. And there are roughly 1,000 of them. And with NEOWISE, because we were able to gain new information about their sizes, we were able to confirm that at this point, more than 90% of all these really large near-Earth objects have been found. This was called the Space Guard goal, and I personally like it because it just sounds so science fiction, you know. So we've done pretty well on the very large ones, but on the smaller objects, which can still be quite hazardous, the picture is less rosy. So if we have the next slide. What we've been able to do is come up with a new estimate of the numbers of near-Earth objects. And in the top row there, the filled-in asteroids, the brown ones, that represents the world's knowledge of the population to date, how many have been discovered. And you can see at the 1 kilometer size range, most of these have been discovered. But at smaller sizes, fewer and fewer have been found, and many more remain to be found. What we found with NEOWISE was actually quite surprising. There are somewhat fewer than we expected. So that's good news, probably, for the hazard, although we still have to focus in on the calculations for the asteroids that are actually most likely to get close to the Earth in the near term. So the blue circles represent the old population estimate. The green ones are our new estimate with NEOWISE. And we can have the last slide there. And this is our new estimate of what the asteroid population looks like. Let's see if we've got any joy on that movie. Okay, good. Right, so you can see lots of swirling red dots, and these are a simulated population of near-Earth objects that we think are out there. These little white and blue dots represent the sample that we observed with NEOWISE, that we actually detected, and this is what we used to make the extrapolation to the whole population. And so now you can get an estimate there of what the old model looked like, and you can see the new model on the other side there. So somewhat fewer, but still lots out there, and lots remaining to be found.
Obviously, because this is an area that science fiction and films love to undertake, you must have a sensibility not only of how well they do the science, but how the women look in the sciences, whether it's Lieutenant Uhura, for example, or the character in Galaxy Quest that Sigourney Weaver played, or Jodie Foster. How do you assess those two things, both the quality of the science in fiction, science fiction, and the way women are portrayed in the sciences?
Sure, sure. Well, so one of the things that Hollywood often gets wrong about asteroids is that, starting with The Empire Strikes Back, which I love, it's a great movie, it's just that you very rarely would see resolved asteroids in the asteroid belt. They would look like dots. So the whole cool scene of zooming around through the asteroids, that really wouldn't happen, unfortunately. They'd be dots. But it'd be so much less exciting for a movie, I suppose, to be zooming around. Whoa, there's a dot way over there, you know. That wouldn't be so good. And the other thing that I think Hollywood gets wrong is that there just aren't very many women in leadership roles in science fiction, in representations. I actually used to read a lot of science fiction, and I still do, but I have to admit it was a real downer that some of the stories were just, I didn't identify with many of the characters, or if I did, they were not women.
And the men wear loose clothes, and the women always wear really tight
Yeah,
clothes.
that's the other thing about science is that what it's really like, science in the movies, everybody looks very glamorous. Science in real life, I wear sweatpants and I program with my glasses on and my hair a mess, and you know, that's more real
We'll make
science.
that movie one of these days.
Yeah.
Amy, thanks very much.
Sure.
Carol Raymond's also here at JPL, principal scientist and deputy principal investigator for the Dawn mission to the asteroid belt, specifically Vesta and Ceres. She's also figuring out the nature of crustal magnetism on Mars, and here she is attracting her own audience.
Thank you, Pat. Well, I'm really delighted to be here today to tell you a bit about Dawn. And I'd like to start with a couple anecdotes while I have my title slide up here. When I was a graduate student at Columbia University, I was, as a freshman graduate student, invited to organize the journal club. And so myself and one of my female colleagues, who was recently elected an AGU fellow, decided that we would invite 50% women and 50% men to speak at our Friday seminar. So we went around to the various professors and asked them for ideas of who we should invite. And we received a lot of resistance to this idea because there just weren't that many qualified women out there to fill up our seminar schedule. But undeterred, we went forward, and we did manage to bring a few women to speak during that semester. A few years later, I was privileged to be there when a very dynamic recent graduate from Brown came to speak to us, and she's sitting to my right here. And I found Maria to be just a wonderful role model and such an accomplished scientist. And I said, I know we were right. They are out there, and we have to all, you know, keep our eyes open and help dispel the myths that, that women just aren't contributing or haven't reached the level of qualification of our male colleagues. So through my career, I've certainly kept that in mind. I've had the privilege of working with just an amazing group of scientists, many of them women. So I'll point out that today that I'm working with one of Margie's colleagues at UCLA, Chris Russell, who is the principal investigator of this mission. And he's been one of the strongest champions for women in science that I've ever come across in the entire community of space science. So kudos to Chris, and one of his graduate students is in the audience today, who I am working with as well. So one more point before I get off this slide. This mission is an international collaboration. We have instruments and scientists from Italy and Germany who are intimately, integrally involved in the mission. And the Italian team in particular is led by a woman, and her deputy is a woman. And they have produced an amazing spectrometer instrument. There are many other women on the team as well, and the reason is that the Italian government invested in a proactive approach many years ago to bring women into science. They really made an effort to attract them, to give them the tools that they need, and the results are nothing less than amazing. Amazing group of people. So now I'll turn to the amazing mission that I've been working on. The Dawn mission, which is launched in 2007. It's in the asteroid belt, in orbit around Vesta. Its targets, Vesta and Ceres, are really special places because in the asteroid belt, which Amy has already given a good introduction to, the main asteroid belt has over 500,000 objects in it, probably upwards of 1 million. And these are the fragments left over from the planet building process. Vesta and Ceres comprise about 40% of the mass of the belt. So these two objects are obviously very special. We call them protoplanets. They're remnants of the planet building process. Equally as special is our spacecraft, because it also launched on a very small rocket. It's the first spacecraft ever to go into orbit about an object in the main belt. It's the first spacecraft that will ever orbit one object, leave it, and then go into orbit around another object. And it'll be the first to visit a dwarf planet, which Ceres was named recently. So let's get an idea of what these things look like and why they're so special. I've given you pictures of Vesta and Ceres next to some objects you're familiar with, Pluto, the sibling dwarf planet to Ceres, and the Earth's moon. You also see pictures of 2 asteroids that have been visited by spacecraft, which are considered large, but as you can see, they're very tiny compared to Vesta and Ceres. These are really small planets, not just asteroids. So Vesta is a tiny planet that formed just after the birth of our sun. It's actually quite similar to the moon. It's dry, it's rocky, it has an iron core, and it's been around for 4.5 billion years, recording the history of the solar system. Its surface is telling us about the intense dynamic bombardment that it has experienced over time. And one of the really interesting things about Vesta is that many of the meteorites that fall to the Earth, in fact 5%, come from Vesta. It's a special class of meteorites called the HEDs. And in fact, we have more meteorites from Vesta than we have from the Moon and Mars combined. So we already know a lot about Vesta, and we want to know what this body is able to tell us in concert with those rocks about the intense dynamic environment, the physical processes, the chemical gradients that were present at the beginning and that influenced the planet building process. Another amazing thing about these 2 bodies is that they're there at all, that they have survived this intense dynamic environment for 4.5 billion years, and they're there to tell us the story. So Ceres is quite different than Vesta. It is not dry, it's very wet. It has a rocky core, which is silicate. It has some silicate which has more water in it on the outside, and then at the outer edge, it's got an ice shell. And underneath that ice shell, there might be a little bit of water. So Ceres has retained water and gases like carbon dioxide and methane over solar system history. Its surface chemistry is expected to be very interesting because it's got a warm surface. And in fact, it shows some specific minerals that are associated with hydrothermal vents on the Earth and that have only been recognized on the Earth and Mars and Ceres. So when we get to Ceres in 2015, we know we're going to find some really interesting things. So next, I'll show you a short tour of Vesta, and then I'm going to give you a little more information on a couple of special places. And the first thing we're going to see is, if my movie will play. Okay, I don't think my movie is going to play. Yes, it is. Okay. So the first thing we're going to see is the Vesta is rotating on its axis. We have some deep troughs around the equator. Then we're going to look at the South Pole, and we're going to see that the South Pole has some very chaotic topography with a lot of ripples in it. And this is the area of a very large impact basin, which you'll see in an upcoming slide. The surface of Vesta is quite smooth and younger looking at the south where this large impact occurred, whereas the north shows many more craters, an older surface. And if we, this is a flyover showing you the topography in that South Polar Basin, coming up over a central mountain, which is one of the highest in the solar system. Here we're looking down into a crater we call Marcia, and you'll see that coming up in a little bit in the north of Vesta. And then I'm going to cut from the movie right now, excuse me, in the interest of time, to go to a little more detail. So this is the large impact basin. It has it's so large that its effects affected the entire asteroid. And those equatorial troughs that I showed you earlier are actually associated with that impact. The middle of the basin has this large central peak. It's one of the highest mountains in the solar system. It rivals Olympus Mons on Mars. It's a very unusual feature, and we generally see extremely steep slopes on Vesta. In addition to the large Rhea Silvia basin, there's an underlying second large basin. So it's clear that these impacts have had a very large effect on the body. And here is Vesta's party dress. This is showing you the spectral data from our Italian spectrometer draped across the surface. And these color variations are identifying minerals, which allow us to identify rocks and give us the ability to do this, this tie back into the meteorites. So we can associate different parts of the surface with the different rock types, and we've confirmed that these rocks have been liberated from Vesta by this giant impact at the South Pole. So now we have a better basis in which to make a geologic history of Vesta and understand its relation to the solar system formation. So I'm going to leave you with this picture of Marcia crater, this beautiful crater in the north, and thank you very much.
You mentioned how inspired you were by Maria's work. I'm sure we're all going to make this point, but was there a mentor or someone who brought you along, or on the other hand, maybe someone who said, nah, science, that's not for you, girly?
No, nobody ever said that to me. There were many mentors along the way, starting in junior high school. People ask that question all the time, and I thought very hard about it, and I can't come up with a single instance of anybody not encouraging me, other than once you get out in the world. I did a lot of work on ships, and I can tell you that's a pretty chauvinistic environment to work in. And there were many men who told me things like, I should just smile and use my feminine charms to get the men to do the work for me, but that's not what I was there for. So yeah, you hear things, you ignore them, you develop a thick skin, and just keep your eye on what your goals are.
Is that the best advice? Just kind of ignore this stuff, let it roll off your backs?
Why not?
Yeah. All right, let's hear from Fiona Harrison. She teaches physics and astronomy at Caltech. She's the PI on NuSTAR. It's part of the program to build the first on-orbit telescope tasked with finding black holes and supernovas and all those extreme galaxy events that we like. Sounds like a reality show. And like a reality show, she's taken leadership roles in these great unknowns.
Okay, so this is a picture of my second child. And my first child, by the way, is a 5-year-old girl. And talk about, what Maria said, worrying about sending your kids off to college. Well, my second child is right now at Vandenberg Air Force Base in a fairing. We're about to put it under an aircraft, fly it from Vandenberg to Kwajalein, which is an atoll in the South Pacific, have the plane take off, have the rocket drop, and 5 seconds later, go up into space, working flawlessly. So, fingers crossed, this is all going to happen in about 2 weeks. So
you're due in 2 weeks?
Yeah, I'm due in 2 weeks. And the problem is, they don't induce. If NASA's behind, then in our case, we do have a few issues making sure the rocket's ready. Sadly, you just have to wait. My project manager told me on the way back from NASA headquarters last night on the plane, he said, well, space science isn't for the impatient. But it's a combination of frustration and exhilaration, kind of like raising children, but focus on the exhilaration, because being able to lead a mission and work with, as Maria said, a smart team of people and achieve something that's never been achieved before, that is a sense of, accomplishment and exhilaration. And 3 weeks from now, I hope to be telling you how everything worked. But let me first, what I really want to focus on first is the exhilaration. Why is it so great to be able to do something new? Well, NuSTAR is going to open a whole new window on the universe. It's going to be the first telescope ever that can take high sensitivity images of the universe in the high energy X-ray band. And we conceived of this in 1995. We had to develop new technologies, new optics, detectors to make this happen. But in the end, on a small mission, so this is NASA's smallest astrophysics platform, we're going to achieve something 100 times that can look 100 times more sensitively with 10 times sharper images than anything that's ever been flown. So if you go to the next view graph, so why do we want to open the universe to high energy X-ray exploration? Well, X-rays are part of the electromagnetic spectrum, just like the infrared light that Amy talked about, and radio waves and optical. But the thing about X-rays is they're emitted from objects that are 10,000 times hotter than our sun, from regions where particles are moving close to the speed of light. And the other thing about the high energy X-ray band, NASA has built telescopes in the low energy X-ray band. By going to higher energy X-rays, these are the same energy X-rays that are used in baggage scanners and in medical X-rays, because they're very penetrating. Rather than just being exotic things, and they are exotic, and we want to study them for that reason, they're also building blocks of the universe, it turns out. And so NuSTAR is going to shed a whole new light on the question of how galaxies and black holes form together. So I want to turn for a minute to talking about the hardware. So this, when I was a postdoc, we wanted to build a sensitive high-energy telescope, but the technologies didn't exist, the optics, the detectors. And I'm a person who has my own lab. I go down there. I spend a lot of time thinking about how to build things. And it's been an amazing effort to work with a lot of talented people to figure out how to build these new optics and detectors. And I'll tell you, when I was a graduate student, I almost gave up because I started to work on a balloon experiment, not this technology, but related. And I was told by my advisor, he said, well, there's a bunch of engineers over here in this group. I want you to go, tell them how to design the system, work with them, to get it to work. And I can tell you, they didn't really like a 20-something-year-old girl, as they called me, coming in and telling them, we're going to do things this way. So I figured very quickly the way to get around this was we're a team. We work together. I listen to you, you listen to me, and just ignore the comments and once you get past that and you start working with people on a personal level, right? It really doesn't make a difference anymore. People don't see you as a young woman. They see you as a scientist and eventually as a leader and somebody they respect. So, but don't give up, because if you can get past that, then you have tremendous opportunities ahead. And here's the opportunity that we realized with my team, which is the spacecraft. You can see 2 X-ray telescopes. That funny cone-shaped thing is a star tracker. There's solar panels that have to unfold after we launch. There it is. It's really beautiful, just like your kids. They're always the cutest one in the class. Next. So the other thing that my kid has to learn to do is extend an optical bench structure after we launch. So this is an animation. Because we're a small mission and X-ray telescopes require a long distance between their optics and their detectors, we are the first mission to fly this novel structure on a telescope, an astronomical telescope, which will unfold to be the size of a school bus after we launch. So this is going to happen 7 days after launch. So this is sort of, I don't know, equivalent maybe to sending your kid to walk to school for the first time. So fingers crossed, 7 days after launch, next.
So we'll take 3 weeks from now, we'll watch.
That's right, hopefully. So after that point, we'll take this image of the high energy universe. That's a glow of unresolved black holes. None of those are real point sources. It's just the glow of the sky and X-rays made by the previous best high-energy X-ray telescope, and we're going to turn it into this. And that is the exhilaration.
That's a better makeover than 17 magazine every day.
That's right.
Fantastic. Thank you so much, Fiona. We've got questions from the audience, I know, but I also know that one of them is going to be about advice for young women going into the sciences. Good advice and advice about things not to do. We can learn from you. Jump in.
Science and engineering are great careers. You should do them. It's a lot of fun. It's hard work, but they're just so much fun. I love my job. I couldn't imagine not being a scientist.
And what shouldn't you do? What are the...
Don't not do science? No. No, I mean, don't be afraid. It's a great career. It's absolutely fabulous.
What are sort of the dumb questions and remarks you've heard on the way to where you are now in your career?
There are a lot of little things, but I think a common theme is keep your eyes on the prize, Just keep going. If you get knocked down, get up. If you get knocked down again, get up again, and just keep going. The most important thing is determination, really.
I might say, don't underestimate yourself. I think that's something that is easy to do when people around you are more blustery than you are. To recognize that, first place, it's not necessary to be an arrogant person to be a very fine scientist. And I think that personality trait is one that some women have to overcome.
The fact that you're all up here means there are probably a lot more mentors than there were 10 and 20 years ago. Were mentors important to you, and do you find young women coming to you now, or even young men, and saying, help me out?
I think one of the things that a lot of women worry about is the balance between work and family. I hear that over and over again. And interestingly, there's a trend that I've seen in some of my colleagues whereby couples will take one position and split it, a tenure track professorship, for instance, and split it so that they can raise a family with equality in the relationship until such time as they're ready to, to take on more. So that's one innovative way to deal with it. But I think the important message is that it's good to see that women can succeed to positions of leadership while still doing all the other things that everybody wants to do, and it is possible. So that I think is one thing that deters women, and one thing that my sister told me is very prevalent in the medical field. More than half the women entering more than half of the people entering medical school are women, but only about a quarter of the doctors are women, because they drop out very quickly, probably because of workload issues and family issues and so forth. So there is a way to achieve this balance. It's not impossible, and in fact, I think your kids really get something out of it to see their parents achieving such things.
That's what I was going to ask Maria.
Yeah, so I have two boys, and when they were growing up, I sat down and I asked them at one point, and I said, would you prefer that I stayed at home rather than having this job that I have where I'm always running around like a crazy person? And my one of the kids looked at me and went, Mom, you're the only mother in the class who shoots lasers in space. And so it wasn't an issue, and in fact it was, for your children, you as a parent, it's all they know. So for my children, I was normal to them, but what I would say is that as a scientist, you have some flexibility in your schedule. So I actually, I remember my one of my sons was a still is a very gifted athlete, and when he was a senior, he was a 3-sport athlete. And I remember during his soccer season, they went to the semifinals of the states, and I missed 2 games over the entire course of the season because I was able to work my schedule around. And I come out here every 2 weeks, so I don't even want to think about how many red eyes I took home in those days. But there's a flexibility in your schedule sometimes when you're a science and engineer, when you say, how do you balance all this stuff? It can be done in some cases a lot easier than you would think, and a lot easier in careers that, other careers where you just have to be sitting at your desk for 8 hours. The nice thing about science and engineering is, it's if you get your job done. And so sometimes there's some play in that, as long as nobody's looking to see if you're sitting at your desk. People are looking to see if your job is done.
Plus you get to shoot lasers into space.
Well,
you have to be smart to get to the position you're all occupied, and the saying is that women have to be twice as smart to be thought half as good. But what are some of the other qualities? I've heard persistence. What else needs to be brought to bear? Margaret?
Well, I was going to make a comment that's not quite an answer to your
Please.
question, but something that I feel was very critical for me, and that I think one has to think hard about, is a supportive partner. Because if your partner is not on to the program, it's going to make it very, very hard to achieve a successful career. So make sure that any partner you hook up with believes in you the way you believe in yourself.
Maria?
Yeah, well, one of the things that, one of the issues about girls going into science and technology is they, when they're in school, when they're in the middle school to high school ages and even college, they don't want to look smarter than the guys, okay, because the guys won't date them. And my advice is, you don't want to be hanging out with loser guys, okay? All right? Okay? Find yourself a great guy who is smart and challenged. Pursue your dreams, and you don't want to go through life, hanging out with somebody who doesn't have, mutual respect is like the most important thing. So, I guess that's my advice.
Wow. Anybody else?
I have a 14-year-old daughter, and that's exactly what I told her.
Well, I tell you, when they're young, it's a little harder because you have to explain why mommy's going to Washington again, and why are you picking me up? But when I told her she could have a dog after my project, the satellite launches, she was happy. And I said, and then I'll walk it with you every day.
Oh, a little together time too.
Yeah, but I think persistence, and for me, I was definitely underconfident in high school and in college. I wasn't the kind of, person who went into college saying, I'm going to be a physicist and a scientist. I thought about a lot of different possibilities, and I loved physics, but I always questioned, did I do well on the test because I got lucky? They asked the questions, that I was looking for. And I think both men and women, but probably more women, tend to be less confident, less sure of themselves. And, that was something for me that I had to get over. So I think developing a sense of confidence, developing, still I teach Physics 1, and most of the questions from my class come from the men in the class. Yeah. Women, even though, they have perfectly, good questions to ask, will hold back and think, I don't want to look silly, I don't want to, expose myself. Whereas men, they really don't mind.
So what have you seen and what have you heard from students that's going on in the classroom to change that?
Yeah, it's hard. You want to try to develop an open style so that students feel comfortable, but I do spend a lot of time talking to my women undergraduates and students who work for me and telling them, look, practice, go to a talk, and just ask a question, just get used to putting yourself out there, because that's what science is all about, exchanging ideas, not being afraid to say, something that may not be right. And, I think that's definitely something that you have to get over. And now I don't, I have no qualms about saying.
Maddie, raising your hand in class saying, hey, I dreamed about this benzene ring thing last night. It couldn't work for everybody. Yeah. On that point about questions, go ahead, I'm sorry.
So I wanted to follow up on that and reiterate what Maria started with about how, working with these incredibly talented, creative people on these missions is really what it's all about. And it's different than what we think of when we're in high school and we take physics and, we're doing problems, and you think of a physicist sitting in their office, with books and writing out formulas, and it couldn't be farther from the truth. What it's really like is being on an elite sports team. You're out there, you're competing for money, you're competing for being the best, you're working in a team, everybody's supporting each other, and you're going after big things, and so it's so interesting, and it's so fulfilling, and it's so active that I think that's what a lot of people don't really recognize when they think about science. They kind of have this view of it being a very static and kind of almost boring career, but it's anything but.
So on the encouragement to ask questions and speak up and not be afraid, here we are at JPL, and I'm asking you to do exactly that. We have a couple people with microphones. Raise your hand if you've got a question. We'd also like to find out who you are and where you are from. So who have we got? Come on, you just heard this here. All right, we have someone here. Yes. Can you stand up and speak into the microphone? Tell us who you are.
Hi, I'm Claire Dickey. I'm a sophomore astrophysics major at Pomona College in Claremont. And you all talked about how you often just ignored the fact that you were the only woman in your class, or that these men didn't necessarily respect you. Did you ever just turn around and say, no, don't call me girl, you can't say these things, or you guys need to bring more women physics PhDs, you need to have more women speakers? Did you ever just turn around and try and talk to the administration or the people around you and actively try and change those things?
Margaret?
I've been on more committees than I would like to remember. And many of them were Committee on the Study of Women in Science, Committee on the Advancement of Women, that kind of thing. And I'd love to tell you the worst story that I encountered that got changed as soon as we discovered it. When I was on the first Committee on the Status of Women at UCLA, we discovered the following regulation. If a woman was a resident of the state of California and married a man from out of state, she lost her in-state status and had to pay out-of-state tuition. If a man was a resident of the state of California and married a woman from out of the state, she became an in-state resident. That regulation got changed before we ever got the report out onto the distributed. So yes, I've been involved. It's been it's an important thing to keep going. Changes are always needed, but then things go back again, and you have to keep alert. And it's really important to think about the people who are coming up behind you and help them too.
It's a shame you have to keep fighting rearguard actions, but there it is. Maria?
Yeah, well, at MIT, actually, the women faculty there have been extremely proactive, and I would just agree with what Maggie said here about constant vigilance. Okay, so when I became department head, I was head of my department. I made 9 hires, 7 of whom were women. Okay, and the way that it was done is that you just had to be very proactive about getting women invited to give a talk. So once somebody comes in, everyone will look at it, and you will get evaluated by the quality of your work. But it was getting over the hump of the invitation list, and so you just have to be extremely proactive about this, because everybody wants great scientists, great engineers. You want to be surrounded by outstanding colleagues, but there's a tendency for people to recommend their former student. And women tend not to be out there, promoting, being self-promoters of themselves. So you really need to go in and read the papers and look at things in more detail. But it really is proactive, and you have to be part of the solution. I mean, you can't sit back and assume that this is all going to get taken care of.
Or assume that your qualities alone are going to advance
exactly.
you. In every profession, you have an editor who would advance a young man saying, he reminds me of me at that age. I'm never going to remind him of him at that age.
Yeah.
So that's the lookout for all of you, I'm sure. Okay, we have another question over here. Who are you? Where do you go to school?
Hi, my name is Andrea Lawler. Thank you all so much for coming, by the way. I go to USC. I'm a screenwriting, electrical engineering double major. And I have 2 questions for you. So my first question is just that a lot of times, I at least have heard in college a few times, whenever an opportunity comes my way maybe, or comes the way of another female engineer, a lot of times they would hear, oh, you only got that because you're a woman. I don't know if you guys ever had that kind of thing happen to you. You guys have nodded. And maybe how you've overcome that bias. And the second question is just that a lot of people may think that the tendency to think that engineering doesn't involve a lot of creativity, when that's usually not the case at all. And I was curious to know, because a lot of people attribute women to being more creative than men, just a fun fact, and how maybe you've incorporated creativity into your own career.
So 2 questions, creativity in your careers, and do people ever say, oh, you only got that job because you're a woman?
Yeah, actually, that is one that you still sometimes just have to swallow. I was told when I got the faculty position at Caltech that I was chosen because I was a woman, and by a number of people. But, you know, ultimately it just comes down to building your confidence and building enough confidence that you just ignore it and you know it's not true. My strategy there was to confront the people who said that and just say, no, I was chosen because they believe that I'm going to do great things, and it's an example of confronting it. I think is good, and just telling people that's not an appropriate response. But you will get it if you're successful. You will hear it, and
Are these people who wanted your job?
Yeah, in part.
I think there's many examples of where women didn't get a job because they were women.
That's also true.
And so, there's a tendency for some men to to think of the flip side. But I think it's more often the case that women don't get the job because they're women, because they don't have the connections. They don't remind the hiring committee of themselves. And there's a saying that says you can't be what you can't see. So you have to know that there are other people like you out there. You have to find them. You have to network. You have to become part of a community whereby you're not seen as the outsider who is somehow special and got this position because of that reason. Because it's for the most part, it's not true.
What about the creativity question?
Well, science is incredibly creative. I mean, so I like to think of it as doing art, but with a different medium. It's basically metal and electronics and weird cryogens and things like that, and and computers. So it's extremely creative. I mean, to be able to come up with missions that are able to survive the rigors of space is really hard. Space is a very strange and alien environment. It's very difficult to work in. So to be able to figure something out that's not going to go horribly wrong, it takes a lot of creativity. And teamwork too. I mean, it's like everybody has said, one of the really fun things about science is you're not working alone usually. You're usually working in big teams. It's kind of like being a crew on a sailing ship, I mean, everybody's pulling ropes and pulling oars and all trying to row in the same direction, and it's really fun. That's, I think, one of the best things. It is like a great sports team.
We have another question over here. Can you tell us who you are? Where do you go to school?
Hi, my name is Amelia Stone. I'm a grad student in the math department at USC. And you said that when people criticize you or assume that you got the position because you're a woman, you go and you confront them. I want to know, at what point do you confront? Because I know a lot of females have issues with people saying, oh, it's because you're a female, you're emotional. So at what point do you confront someone, or should you just ignore it? Should you turn the other cheek?
Well, in my case, the way that I dealt with it was to confront, to talk to the people. When I heard about it, when somebody said that or said it behind my back, because I thought it was important. That it's just not an acceptable attitude. I mean, I've been on the other side of hiring committees now. I've hired, like Maria, many faculty members, and I'll tell you, what you care about is talent. You care about who's going to make an impact. It is true. In some cases, if the person isn't flashy or have the connections, you have to read the papers, you have to do more diligence. But I'll tell you, we hire people succeed because they are good. And I think it's important to just iterate that message. I mean, but it is, it's uncomfortable.
I'd be more inclined to throw it back, with a bumper sticker like, my brain is bigger than your you-know-what. I don't know how that would work for you.
Well, there's a phenomenon called imposter syndrome that I've heard discussed, and psychologists use this term to talk about basically the notion that, oh, you think to yourself, well, I'm only able to do this because I'm a woman, or I shouldn't be here, I don't deserve this. I'm a fake, and everybody
question yourself.
Yeah, and everybody will find out, and that's imposter syndrome. It's you got to get past it. And that's something to when you find yourself falling into those behaviors, you have to recognize it and say, oh, okay, I'm doing this behavior, and I want to try to change my behavior because that's the only thing I can change. I can change myself. And I'm not going to listen to that voice telling me that I don't belong here.
And to tell yourself, I have this job because I deserve this job.
Yeah, and you deserve it, yeah. That's
But
right.
I would also say that, whether you confront somebody or not, I mean, the best way to deal with comments like that is to do really good work, okay? And ultimately, things will take care of themselves.
Over here, we have a question. Who are you? Where do you go to school?
Thank you. My name is Dina Anderson. I'm an undergraduate at California State University of San Bernardino. And my question to you is, because of the increased education and the proactive stance you're taking toward hiring more women, do you find that there are more opportunities for women, or have the opportunity levels stayed the same and we're just increasing the education level for these women and making them aware that the opportunities are there?
Margaret, maybe you could, I don't know if you've seen the changes over years of the numbers, the availabilities, and that particular, calculation you'd like.
Okay. I'm not sure that I am answering exactly the question you're asking, but the desire to add women to the faculties in sciences is not uniformly spread through the hiring process at the university. There are a lot of people in all universities who are really eager to recruit women and to identify outstanding women. There are others who who have very little interest in this, and so it varies over time which element is dominant. There was a burst of interest in hiring women during the Johnson administration, when Title VII of the Civil Rights Act was passed, the one that said you can't discriminate on the basis of gender. And there was a really serious effort to hire women, and there were even special positions set aside. If you could find an extremely gifted woman, a department could get an extra appointment. And then people began to get smug, and there was much less direct attempt to hire women. And then in California, we passed the proposition that said that you couldn't take direct action for affirmative action in hiring. So it's gone up and down. I think right now it's kind of somewhere in the middle.
Is there a critical mass that we have yet to achieve with the number of women in the universities and in academic positions?
I think in academia, in the sciences, we haven't reached the critical. There have been studies that suggest that you need at least a third women for people to stop thinking about a person as being a woman faculty member and think of her as being a physics faculty member. So that we haven't reached in the physical sciences.
Carol?
Yeah, I would say that I think at the Jet Propulsion Lab, that critical mass has been reached. As Charles was saying, Charles is also one of these people who's very proactive. We have 2 members of the EC. You're seeing women in the top positions. You're seeing women leading technology developments, which is one area that was often dominated by men, leading projects. And when I came here, the management of projects was all male. All of the highly technical fields were led by males, and women were generally in human resources or some more soft positions. And that's changed entirely. So I see that we've reached this critical mass, and no longer is there really a gender issue here at JPL.
We have another question up here.
Hi, yes, I'm Lauren Edgar. I'm a geology student at Caltech, and I was wondering if there was anything in particular that you did to prepare yourselves, not just for careers in science and engineering, but to take on leadership roles in some of these missions. Was it something that you always thought that you wanted to do, or did you seize the opportunity when it came about?
This is not related to the mission, although I think they're related. But when I was negotiating to become head of my department and met with the dean, he said, you'll be fine, you've raised children. And, but and actually, I think that he was correct, and actually I think that did actually apply on the mission side too, because in a mission, you want to give everybody an opportunity, and you want everybody to do their best, because that's the only way that you, and it's basically the same qualities that you have as a parent, okay? And so for me, that's, you know, something that I've looked at in that way. But there's, you know, there's two issues. There's leadership, and then there's management. And the management, I don't know, you know, there are ways to pick that up that could be more on the coursework side. But I think on the leadership side, it's going out and just trying to do what you think is the best thing, and to really be receptive to input from others, okay? If you're not receptive to the input of others who have good ideas, then I think that you can't go nearly as far.
Yeah, then you're the boss but not the leader. So, over here.
Hi, my name is Kapana Ramsey, and I'm a student at Scripps College, which happens to be a women's college. I just wondered, have you ever found yourselves being discouraged by the women in your life for doing the sciences? Because guaranteed, like, I always have a physics problem that I find particularly hard, and I tend to vent to my friends. And once a friend of mine said, well, no one's telling you to do the sciences. I wonder if you guys have ever had anything like that, and how you dealt with it.
We tend to think of women as practicing solidarity, but sometimes it's not always the case.
Well, I guess I would say that women tend to be the hardest critics on other women, okay? Because you want to avoid any issue that any woman got anything because she was a woman. So I don't know, Maggie, maybe you can comment on that, but I think women look at women and say, you know, look, you got to be better than that. And
I think you've got a point.
Yeah, I think that's actually true.
Question here?
Hi, my name is Yao Hackett. I haven't been living in America only 9 years. Obviously, I'm 44 years old. It's a very old age. I'm from CSU Long Beach at Lancaster, which is a very small group engineering program. My situation is, since that is a very small group, only have 9 students in EE. So, and most of the teacher is part-time, so they obviously don't have office hours, and so it's very difficult to handle with them. So only can see the professor is only just class time. So I have a really little bit of hard time to continue to take a class. So I told my friend, so they all suggest me moving to another university, so which is I was in the CSU San Jose. So beyond your experience, what do you think?
Thank you. And
thank you.
Here's a situation where the professor's part-time, no office hours, no access to the kind of advice that you were talking about. Should people look for different universities, if they can, in these cases, that may be more able to listen and to lend some advice to them?
That's certainly a good option. Another is that there are associations, national, state, of students, and you can always find people that can mentor you and help you through those organizations. So I would look for what other...
what kind of organizations for engineering, for
there's
physics?
It's a National Association of Geoscience. Well, there's an Association of Women Geoscientists. That's kind of at a professional level. There are other graduate student associations that are usually active on most campuses. So I don't know in some specific examples, but certainly, you know, the Association of Women in Geosciences would be a place to go to if you're in geosciences. But you know, you get the point.
But professional groups are beyond the immediate physical presence of a faculty member or the absence of a faculty member. Good. Okay, over here.
Hi, my name is Savannah Vanessa, and I'm a graduating senior in California State University, Northridge, studying mechanical engineering and minoring in writing and rhetoric. I wanted to ask, a few years ago I was doing some research on the number of women that were studying in science and engineering, and I did notice that the flood of women during the 60s and the 70s, but what caught my attention was during the 70s, during the flood of the women, there was a sudden decrease in men actually going into engineering and the sciences, and some of the papers had suggested that it was just a negative reaction by the men for the sudden increase in number of women. I wanted to ask your opinions. Do you think there is any truth in these suggestions, or have you ever encountered any such negative reactions?
Thank you. And there was a phenomenon that you saw in the Soviet Union, which would brag, oh, we have 70% of our doctors are women, but at the same time, that profession became devalued because more women went into it. And I think that's a good question. Anybody want to speak to it?
I've never encountered any attitudes like that. And I tend to think that engineering is still a male, associated with being male dominated. And so therefore, men wouldn't have that kind of backlash mentality. But I'll say that what I saw in the 80s is that very smart people, including some of the people I went to graduate school with, went to Wall Street because that's where the money was. So there's, people shift around for different reasons, but no, I haven't experienced that.
Thank you all for coming. Terrific panel. Will you please thank our panelists?
Thank you, Pat. Thank you to the panelists here for a really enlightening conversation. Welcome back. We have assembled an outstanding panel of JPL women leaders in all aspects of what we do here, from flight project to science to technology, engineering, line and executive management. Here to engage them in a conversation and take your questions is our Director of Human Resources, Cosette Hart. Cosette, you have the floor.
I know we left off at a very engaging Q&A, and I hope we can carry that into this next session. I'm just going to be sort of kicking off some questions for this group of panelists. These are all very successful women here at JPL, and I think they're anxious to answer some of the same questions that the earlier panel got. So I think if you've got the questions, write them down. We'll make sure there's plenty of time at the end for that. I'm going to just quickly go through a little bit about each person so that you know who we have here very briefly. It certainly doesn't do their careers justice. And hopefully as we talk, some of what their highlights of their career will come out as part of that. So thank you very much. First to my left, immediate left, is Dr. Meg Powell-Meeks. She's the Associate Chief Information Officer here at JPL. She's earned a bachelor's degree in physics and then went on and earned advanced degrees in engineering management, computer science, and information systems. Next to Meg is Elizabeth K.M. She is our manager for instrument software and science data systems. Liz holds a bachelor's degree in math, 2 degrees in math, computer science, and business administration. Next to Elizabeth is Dr. Diane Evans. She is an executive for Earth Science and Technology. She's been a project scientist, a chief scientist, and held increasingly higher levels of management responsibilities throughout her career with JPL. She holds a bachelor's, master's, and doctoral degree in geological sciences. Next is Dr. Claudia Alexander. She is a project scientist for Rosetta, which is one of our international missions in our Solar System Exploration Directorate. She holds a degree in engineering and received her doctorate in atmosphere and space science.
Next, we have Jan Chodas. She's an executive for our Safety and Mission Success organization. She most recently was our project manager for Juno, which is a mission that we have going to Jupiter. She holds undergraduate and graduate degrees in aerospace engineering. Next is Kendra Short. She's a senior manager here in our Mechanical Systems division. She holds a bachelor's degree in mechanical and aerospace engineering and a master's in aero and astro engineering. And finally, last but not least, is Dr. Rosalie Lopez. She's a planetary scientist in our Solar System Exploration Directorate. She holds a degree in astronomy and received a doctorate in planetary science, and she's our leading volcano specialist here at JPL. So first of all, I'd just like to kick this off, and I'm going to direct the first question to Mag. I've just gone through lots of advanced degrees here. How important do you think it is to have an advanced degree or continue on with your education and be successful?
Sure. Well, for me, I found having an advanced degree very helpful in my career development. For example, when I came to JPL, I had a degree in physics and some training in engineering management. So my first job was a junior instrumentations engineer. And although I enjoyed working with hardware, I really became excited when I had a chance to work on a data acquisition system that involved computers and software that acquired and analyzed data. And that inspired me to go back to school and study computers and computer science, information systems. And the natural integration of those technical areas, I think, opened a lot of doors for me to pursue other jobs across the laboratory. And it turned out that I moved into the IT organization a little bit, and right at the time JPL was looking at outsourcing. And I did my dissertation in that area, and it turns out that I was able to contribute, I think, to learning how to start up an organization, how to transition people, and went to industry and learned a lot about business, how to do business management, and got the opportunity to come back to JPL and work in both engineering and IT. So that's a perfect blend, I think, of having, when you continue school, how many doors can open and the different paths your career can take. So for me, it's been a wonderful thing. I think you should continue.
Any others here who decided that they needed that for their career as well?
Yeah, I think especially in the science area here, most of the scientists here have advanced degrees. I do think that that's very important for JPL.
Yes, when you do an advanced degree, that's when you really learn to do research. So if you want to do research, it's very important to have that. And you might also find slightly different areas of research that you enjoy. I actually started out with an undergraduate in astronomy, but in my final year I took a class in planetary geology, and my professor was a volcanologist, and that's where I decided to go into geology and volcanology.
How about those of you who have been in line management positions and you're looking at students and graduates? How do you look at undergraduate degree versus advanced degree versus PhDs?
Cosette, I can comment from my own personal experience. I did an undergraduate degree in aerospace engineering, but that curriculum was broad engineering and then broad aerospace engineering. It wasn't until my master's degree that I was able to focus in on dynamics and control of spacecraft. And so having that opportunity to do a master's in a particular area made it much easier for me to look at JPL and decide what part of JPL I was most interested in applying to when I was graduating from my master's program. So I would encourage folks to think of the master's and PhD opportunities as ones where you can actually specialize, dive deeper into your technical interests, maybe try something different, as illustrated by Mag's career, but it really does pay off in many perspectives.
Go ahead. I'd like to add that I think getting an advanced degree helps to open up your mind to what you don't know. That when I see people who stop at a master's degree and then want to solve the universe, that it was that extra step of getting a PhD that helped me to understand that there's so much more, and to be respectful of the areas that I don't know, and make sure I have someone on my team who can cover that and not think that I can do all those things myself.
I'd like to offer from my perspective as a hiring manager and from my own personal experience, there's different ways you can go about getting advanced degrees. You don't have to stay in school continuously as a bachelor's and go right into a master's or PhD program. I know I came to JPL after my bachelor's degree and had a chance to sort of see how my education was applied in a working environment, and how the things that I learned, what parts of those were important in the work world and the application to spacecraft design. Then I chose to go back to school after a couple of years of working, and I was able to focus in on what I really wanted to do. And it made me a better student in a graduate program, having had some work experience. So JPL hires a lot of bachelor's students, but we have good programs and the encouragement to continue to go back and learn, either through an academic program or through professional development in whatever company you might hire into, is absolutely important. And there's different ways to do it. You don't have to stay in school until you get the final degree. Getting a little work experience sprinkled in there is also a good piece of advice.
Yeah, I want to add, to Kendra's statement. As the line managers, I found out, a lot of students, they even before they complete the bachelor degree, JPL do offer different type of programs, such as a summer intern, or we call academic part-time, program, especially for local universities. It really gives them an opportunity to just come in and have a hands-on experience, and at the same time, you can just decide if this is really the career path you want to take. Okay, and then they probably, can get a job as a bachelor degree coming in and decide 2 years later, I want to go back for a master degree. So there are different ways approaching it, and there are a lot of opportunity for the students.
So the next question I want to direct to the scientists here. Diane, I mentioned that you were a chief scientist, you were a PI, and you're a PI, Claudia, and Rosalie, you're a planetary scientist. What does doing research at JPL entail, and what is that like as a career, sort of the highs and lows that you might have experienced and hallmarks that you have from that? Start with you.
I guess I can start. The role is, there are lots of different roles that the scientists play here. From my own personal perspective, I have always done my own research, and then, but actually one of the things that I found early on, maybe even more satisfying, was to be a bridge to the outside community, because after you're at JPL for a while, you really get to learn how important engineering is and to make things happen. And so we're very lucky here that we have such an incredible engineering staff. And so I really thought one of the exciting things was to introduce the external science community to some extent to the incredible technology and engineering capabilities JPL had. And that's, I was able to do that through being a project scientist, and then certainly in my role now, that's one of the most fun I have is people getting so excited about the capabilities we have here at JPL to make their science possible.
So when I moved into my new neighborhood, I met my neighbors, and 2 of them told me they were scientists, and first I laughed, and was like, who does that? And then I did not work at JPL at the time, I'll have to say that first. And then I asked one of them what they told me that they studied the rings of Saturn. And then I really laughed. It's like, you actually get paid to do this. Rosalie, tell us about planetary science.
That's the amazing thing. We get paid to do work that we really love. I came to JPL because I really wanted to become involved in missions. I really like this feeling of exploration, of sending a spacecraft somewhere that we haven't been before and finding out things that we didn't know about. And I came to JPL as a postdoc. I was living in England at the time, and I had the chance to come here for 2 years, and now 22 years later, I'm still here. And during my postdoc, I got to know people who were working on the Galileo project with the infrared instrument, and I became interested in what they were doing, and they liked me, and they offered me a job. And in fact, I had never worked with an infrared instrument before, but luckily the principal investigator said, oh, don't worry, you learn very quickly. And in fact, I jumped in and I did learn. And after that project came to an end, in fact, Margie and I were working on the same project on Galileo. And after that came to an end, I actually joined the Cassini mission, which is now around Saturn and has the scientists who are studying the rings of Saturn. But now I'm working on a radar instrument. That's Diane's specialty. And again, at first I thought, I really don't know anything about radar, but again, the answer was, you know, you learn. So I think that there is this, it's a challenge in a way, but you jump in and do the best you can. And I think it makes you a better scientist when you're broader.
Let me throw in that one of the differences with an academic scientist is that, and they tell you, you know, oh, it's just like being a professor, except that you have missions instead of committees and all that other stuff that professors do. And at first, when Rosalie and I kind of started together, and it's actually quite difficult to go back and forth between the mission work and the kind of publication work that you do, the publisher-parish environment. And so that's a little bit hard to deal with. But then after you kind of make the adjustment, you are part of, you know, the nation's exploration program. And you're doing what Diane talked about, the beautiful marriage of science and engineering that is unique to JPL, and it becomes an incredible career path.
So our lab director, while he didn't say it today, he usually does to our workforce and others, that we do here what is impossible, what the rest of the world cannot do. The problems don't come to us unless they're unsolvable. And so I'll direct my first question on this to Kendra. You know, how do we inspire the people here to actually solve the unsolvable as a leader?
I would have to say the first thing we do is we hire very, very smart people. I don't know how you could put that in a job application or a job description, but we try and hire the best and the brightest that we can across the nation. And usually what comes along with that is a lot of passion for what they want to do, whether it's the mechanical engineering or the science or the electrical engineering. And that passion is really the internal motivation for them to do the impossible. We have a lot of people that are personally dedicated that will come in on the weekends because they know there's a tough problem that needs to be solved and they just can't stop thinking about it. So to start with, we have a workforce that doesn't need a lot of inspiration. They come with that built in. But once they get into project work at JPL, the demands of a mission and a flight project are pretty high. There's a launch window that has to be met. There's not a lot of extra time to sort of noodle around on tough problems, and you've got to get a solution. That's the whole point of engineering is building something that does what you want it to do. And so the inspiration or the leadership that people can apply throughout a mission is to make sure people are enjoying what they're doing, they're well matched to their talents, and that you continue to let them know the importance of the work that they're doing and that the contributions they're making on an individual one-by-one basis are incredibly valuable to the overall result and the overall goal. The first panel this morning talked about we all have a role to play on a team. It's, you know, we're achieving something as a group that's bigger than anything we can do by ourselves. And knowing that you played one particular role on that team can be very inspiring to people. And so that's sort of the environment that you need to create when you want people to give their heart and soul to the job that they're doing. So that's what we have here.
So do you see that, do women bring different characteristics to those teams and success than men, or is it neutral in the workplace? What do you find in terms of the characteristics that people bring?
I'll go ahead and follow up. It takes all kinds of people to succeed on a mission. It takes the very deep intellectual thinkers. It takes the very creative and blue sky thinkers. It takes the people that are very good with hand assembly of the hardware that we build. It also takes people that can think through a problem that nobody's ever solved before. It also takes all kinds of demographics, and one of those demographics is gender. And you have to recognize that people bring different perspectives to a team. There are shy, introverted people, there are outgoing people, there are men, there are women, there are senior, highly experienced people, there are young people of you know, the new generation. And it's that mix of different perspectives on the problem that go towards success. And one of those differences is gender, and you have to recognize that. Women do approach a problem a little differently. They have different social interaction approaches, and that's just one of the things that contributes to success, but it's not the only thing.
Let me throw in something, because when I first became a manager at JPL, I actually had some women take me aside and say, don't worry if your management style is decidedly different from the guys who you work with. And I was going into a division here at JPL where there were mostly male managers. And I was a little bit nervous about that. I tend to be a team builder, and I really work on consensus building. And there's another management style called top-down, and a lot of our guys are more comfortable with that style of management. But I have learned really that it's more personality oriented. That is not necessarily a gender issue. So it took me a while to learn that, though.
Yeah, I totally agree, and I agree with what Kendra said. It takes all kinds of people, and that's what makes a team successful. And what you said earlier about doing things that are impossible, I started out on the Galileo mission that Margie and Claudia were on, and that mission had a lot of problems. In fact, at times it looked like it was impossible. And what was so inspiring about being at JPL was that, nothing was impossible. We just got people together and teams together, the engineering teams, the science teams, and we just solved all the problems. And we did the mission perhaps a little bit differently than, for example, our main communications antenna didn't open. So instead of taking a zillion images, for example, you had to think very carefully about which ones to take that would answer your science questions. So I likened it before to a lot of missions. I like a tourist with a point-and-shoot camera, and Galileo was like Ansel Adams, really planning everything. But so it took a lot of creativity, but what at one time looked impossible because of some engineering problems, in the end, I think made the mission more successful.
I've always wanted to do an interview of the people that work here and sort of why did you come here? At what point in your career or in your life did you know this is what you wanted to do? And I'm sure there's an audience here of people that aren't really sure what they want to do. How did you decide? And I'll start with you, Liz. At what point did you decide this is what you wanted to do, and what factors play into that, and how does it happen?
Let me tell you, I think my story might be very different than my fellow panelists over here. Actually, for me, it's by luck. I didn't know that I'm going to be working at JPL at the very beginning, because I started with a business administration degree my first year of college, and just happened that I did well in the mathematics and programming class. So my professor at that time said, "Hey, why not double major?" I say, wow, private school, 4 years I had to finish. But I did it. So, and also, kind of at that point, I kind of had to decide if I want to, go to in a technical field, or do I want to be a buyer for Macy's. And that is a true story. And it just happened that at that time, before I graduated, I was hired as an intern, and I started a project, and I really, really have fun and inspired by a lot of people over here at JPL. And it's really the opportunity that they have given me and helped me decide what my career path is going to be. So a lot of times, you start with something very different, and along the way, you have people helping you and mentoring you, and at that moment, you start deciding. So you think that, my business degree probably is totally, you can just, toss it and it's not going to be useful in this environment. For this environment particularly, even though it's very scientifically focused, leadership skill and business administration, knowledge, it become critical, especially you're managing a large organization, retaining right people and get the people together, create the right capabilities, and moving forward, having that vision. So all those things are, not just what you learn at that moment, and it's really how you infuse it and apply it. So that's just my little story. Very different, I bet.
You know, it's funny how you find out that you actually have a lot more in common than you thought. Your story is almost identical to my own. I always say that I'm here at JPL by accident. I came from what I would call probably not a very popular school, a school that JPL would normally recruit from. And I didn't know a lot about JPL, but there was an opportunity at my campus that invited us to come and apply for a job here. They had 2 positions open, and for co-op students. And as soon as I saw the announcement, I grabbed my roommate and I said, let's go, and took the invitation down to make sure nobody could go to California. Now, our focus was getting to California, and it wasn't about JPL at the time, but I can tell you when I got here as a co-op student, it's a place like no other. We had people who helped us with our homework. I mean, I remember staying in school with tuition reimbursement and going to school in the evenings and taking on my advanced studies, as I mentioned before, and how passionate the scientists were, the engineers were, in helping new people come along and get business done and get on the right path. So actually, we're not that far, not that different, but the environment is what makes the difference, and I'm so glad that I did take that sheet of paper down and prevent everybody else from getting here.
Oh, very good. Anybody who decided at 5 this is what they wanted to do?
Go ahead. I wanted to be an astronaut. I still do. I applied. I didn't really make it, so I'm still here.
We're glad.
I think I'm a little too old now to join the astronaut corps, but you know, my thought was I wanted to be an astronaut. My dad was an engineer, and I was good with math and science all through grade school, so I kind of knew what path I was going to be on from the very beginning, and I love outer space. I'm one of those engineers that looks at what the scientists do with awe, and I'm glad I can help achieve their vision. But you know, having a goal of being an astronaut, that's kind of a narrow top of the pyramid, and so you have to sort of enjoy the journey on the way. And so JPL was the best place to pursue the passion of space and, you know, apply to the astronaut program on the side. But like I said, I think I'm a little too old for that now.
Yeah, well, we have something in common. I grew up with the Apollo program, and again, I wanted to become an astronaut. But I realized even from a very early age that I had several problems. One, being female at that time, only one Russian woman had gone into space. The second, I'm Brazilian. I grew up in Brazil, and there weren't any Brazilian astronauts. And the third problem is that I have terrible eyesight. I wear contact lenses. So I decided, in fact, you know, now the first 2 problems don't matter, but the eyesight still matters. But so I decided from quite an early age that I was going to do the next best thing. I was going to become a scientist and work for NASA.
Very good. So I think this morning we were talking about, or in the earlier panel, about mentors and how they play a part. And I know, again, this audience may be interested in really what is a mentor relationship and how does it help and what do you want out of that relationship? How does it help you? And I'll start that one over with you, Meg.
Okay. I was very fortunate to have several mentors in my career. The very first mentor I had, I would say I was in the 10th grade when my teacher noticed that I was very good and very strong in math and science, when a lot of people in our class would tend to go to non-technical degrees and pursuits if they went to college. She strongly encouraged me to pursue math and science and technology, which I did. And so I would count her as my very first mentor, and that was putting me on the path, I think, that brought me here. But when I got to JPL, I actually found 2 great mentors, and they both gave me 2 different perspectives on what my career could be and what my career opportunities could be if I created them myself, actually. The first person that I remember, his name was Ed Davis. He was a division manager here at JPL. And I remember when he told me, he said, I think I noticed something in you. You're really good with, you have a passion for people. You have a passion for working with teams and working on teams. I can see you in line management. I said, oh, yeah. I can't wait. One day I want to be a group manager. I can't wait. He says, oh, you got to dream bigger. I want you to dream way bigger than that. And today I'm in a job that's bigger than the job that he had, which is amazing. And I did have the job that he had. At the time, I wasn't thinking along that line, but he gave me some tips about line management and how to pursue opportunities there. Now, a different mentor that I also found at JPL was one who was on the project side of the house. And that person talked about how work flowed at JPL. At that time, I was a very young engineer and didn't know a lot about all of JPL. I knew about my organization, I knew about my group, I knew about my team, but I didn't know a lot about how work flowed through JPL as a business. And what he did is he sat down and he showed me how work came into JPL. He showed me every directorate and every directorate's purpose. And getting the bigger picture helped me see how I could move around and navigate. And when I talked to you earlier about the fact that I moved around, I was able to do that because this person said, here are the kind of things you want to do. You want to get those experiences to prepare you to become a line manager. So I think you look for different things based on where you are in your career. And I think that they can offer coaching, they can offer inspiration, they can also guide you technically into what programs to take or which ones to avoid. And so I think that having mentors, though, makes a huge difference. And I think that's one of the first things you should think about doing when you join any company, any career. I think you should do that.
Other thoughts here? Other experiences?
I think mentors, I know no one's ever walked in my door and said, why don't you please mentor me? I think people choose each other based on similarities of temperament and personality. You recognize someone who's like you and you know how to advise that person. So I had actually a project manager, I was yelling at someone on the phone. And this guy walked in my office and said, no, I don't ever want to hear that tone of voice out of you again. And I have to admit, I have this kind of 180 degrees the opposite of the mild-mannered person, which we don't ever want to see that person come out of its box. And he actually then started coaching me in a very profound way. So that's how mentoring happens, really. But it's important to recognize when that's happening. And it's important to seize on those opportunities. I think almost everyone at JPL agrees it's impossible to have a successful career without good mentoring.
So someone who sees your potential, somebody who shows you how things work, how the work gets done and how it really works, aside from what the book says, how things really get done, and someone who puts you in check when you need to be in check and tells you somewhat how to behave if you need that.
Who levels with you.
And I could add to those, that list of characteristics, Cosette, by saying also someone who delegates responsibility to you and watches to see you rise to the occasion. I had that opportunity in a similar way to Mag in terms of group supervisor helping me through the life cycle of a project. I was a member of the group, he was the group supervisor and had years more experience than I did at that time. And so he kind of coached me along the way, this is what we do here, this is why this is going on. But then he made me a group leader in charge of part of the group and delegated a lot of his group supervisor responsibilities to me so that I would have the opportunity under his guidance to make my own decisions in conference. I could always have him there as a resource. But that delegation of responsibility and empowerment, I find that 99% of the folks at JPL, if you delegate and empower them, they will rise to the occasion and surpass your expectations.
Right. That's true. So in terms of your guys' careers, I was with Charles talking to the group of early career hires that we have here, I think it was last year, and one of the employees stood up and said, I need to know where I'm going to be in 5 years. I want to know what position I'm going to have, and so for that person, structure was important. How have you found careers to develop here? Was it a linear path that made sense according to the discipline that you chose at the time? Or was it a windy path? Or just opportunities that happened to open up at the time? I'll start with you, Jan.
Interesting question.
Yeah.
I would say that careers happen both ways. My personal experience was more, I did not have a 5-year plan or a 10-year plan or a vision to be a division manager. I took advantage of opportunities as they came by. When I started at JPL in 1980, I joined the Galileo project as a dynamics and control analyst because I had just graduated with my master's in dynamics and control of spacecraft, so I had the technical background. And so I joined a group and I started designing control laws and testing them in the flight software and in our test lab. And I found by that experience that I was more interested in more the systems aspect of the job, so I moved slightly in the technical arena to kind of broaden my focus more at a technical systems engineering subsystem, looking across the whole dimension of the attitude control system. So I took advantage of the way the project lifecycle was progressing to move into a broader technical role. And then I'd always been a really well-organized person, and so planning, scheduling, anticipating problems, trying to fend them off early was really a natural for me. So I started becoming a technical manager of a small team, and there was an opportunity to do that, again, in the context of the Galileo project. And so I was able to move into that arena and find that I really blossomed in the technical management arena, probably more so than the deep technical folks that Kendra referred to earlier. JPL is full of brilliant, very deep, highly technical folks, and that just wasn't my strength as much as the management aspect of the job. And so I had opportunities to become the technical manager of the Galileo attitude control subsystem. So again, staying technical, but from a management perspective. Then I moved on to the Cassini project. I did the same type of technical management. And then JPL prizes folks who have done both technical management and line management. And so they encourage us to get flavors of both sides of our matrix organization. So I had opportunities, again, that weren't planned in ahead, or I wasn't looking on a 5 or 10-year horizon to do that, but I was able to move into some line management positions, bounce back to project, line, to where I am today.
What about you, Diane? You came with a geology degree. Who knew you'd be heading up the largest division of JPL right now in terms of work for the future?
Well, I think, again, when it became clear that I really enjoyed bringing together science, technology, and engineering and creating something of it, creating missions out of that, or working with a team of people to do that. And I've always had I did my PhD on Mars geology, but I really, have a passion for earth science. And really, when Charles started the Earth Science Directorate, when he became director of JPL, and he asked me to lead that, that was a huge step for me. But by having really great people in the directorate, we've been able to accomplish a lot and start a lot of new missions, launch a lot of new missions, get the science data down. So it's been, really, that's been really one of the main things.
That's great.
Yeah, I'd like to, my perspective on career advancement is, a lot of people think it's a straight line upward, and, your next step has to be to the next level up. And you hear a lot of comments like, I need to know where I'm going to be in 5 years, I need to know how to get to the next promotion or what have you. But I try to encourage the folks that I've advised and the folks that I've hired, when I was a group supervisor and trying to mentor folks. A career is a pyramid structure, and your career should go back and forth along one level for a while before you take the step to the next rung of the ladder or the next level of the pyramid. You want to explore the breadth of what you're doing in a particular area as much as you possibly can, because that will make you a stronger person at the next level up. And whether it's, getting the breadth of all of the engineering disciplines that we have at JPL before you become a flight system manager, because then you have to be seeing and managing and trading off the risks of all of those disciplines. The better you understand that, the better you'll do that job. And so I try to encourage people that their moves in their career should be sideways a lot of the time, and exploring the breadth of the challenges that you can have before you're ready to move into an increased level of responsibility, and kind of view that as a pyramid, and really explore those levels and those layers as much as you can. And don't be so worried about when you get to the next level up. So.
I think I need to throw in a word about a science career where, in general, scientists are encouraged to have great depth on a very narrow area. To become the world's leading expert on droplets of a certain size. When I was in the science division, my manager, that was my performance evaluation for a couple of years straight. It was, You have to become very highly focused and narrowly focused, and also at JPL become the world's leading expert on something. He told me that my very first year, and I pushed the paper back to him and said, that is so arrogant to think that you are going to be the world's leading expert on something. And he pushed the paper back to me and he said, you better figure out what it is. So in science, you know, it's important to be the world's leading expert, but even in science, scientists end up making leaps. One of my colleagues made this leap from being the world's leading expert on Io and fiery volcanism to being the world's leading expert on icy moons, and he did that in about 3 months. And he said, wink, wink, you know, suddenly I went from, you know, fiery moons to icy moons, and I'm the world's leading expert. But even in science, you have to learn when to go to the next horizontal area in order to continue your career. So
Yes,
you
what I
resonated
was
that with
talking
Rosalind?
about before, that I mean, my expertise is in planetary geology, but I have applied it to Io, to icy moons, to Mars. I started out like Diane on geology of Mars. And so you have your core expertise, but you can then apply to different bodies using different techniques, imaging, infrared, radar. You know, I don't know where I'm going to go next, but it's wherever the next opportunity is. I have said that I'll change wavelength for money. I think there is an advantage also in being broad because you can make connections rather than being, you know, just an expert on that narrow drop.
All right.
And it also makes you a better manager. I'm now also a line manager. I have worked on research on flight projects, line management. So again, I've gone kind of sideways and up.
All right. So many in this room, I'm sure, want to have a life of travel and seeing lots of the world. It's all ahead of them. I know a couple of you here have had a lot of international travel, and why don't you talk a little bit about how, directing this Diane and Rosalie, Diane first, how did that happen, and what were the hallmarks of that?
Yeah, well, a couple things. One is certainly to do geology. A lot of the work that we did was in the early days of developing remote sensing technology, and so we would do a lot of field work. But then more recently, of course, most of our missions have international partners. This is, just to make stronger case for the mission, and also, it is just one planet that we're all living on. We're all sharing. And so quite a bit of the travel I've been doing more recently has been in association with the missions that we've been working on. The most recent one, Aquarius, which launched last June, turned out to be joint with Argentina and Brazil. And we're hoping to do future missions with Brazil. So that's really afforded quite a bit of international travel.
Yes, when I was an astronomy student and taking a class in planetary geology, I didn't know then that that's what I was going to fall in love with. But one of the things that attracted my attention was that one day the professor didn't come to class, and he sent a substitute, and the substitute said, well, Mount Etna erupted, and the professor had to go. And I thought, that sounds like so much fun. And so when I was doing my PhD, I was in the UK's, what they call the volcanic eruption surveillance team, and I got to go to erupting volcanoes and really fell in love with them. And I have done field work, but these days I do less field work, but more international travel because, for example, the Cassini mission is joint with the European Space Agency and the Italian Space Agency, so we have more collaborations.
So for some on this setting, that would not present excitement for them. They've got work-life balance issues and maybe making career choices to not have to travel. Do we have some examples? I think, Jan, you may be one that can talk about that.
Certainly. I had enjoyed about 10 years of my career at JPL when my husband and I decided it was time to start a family. When I had my first child, I chose to take 6 months off and stay at home with the baby. And then when I came back to JPL, I worked part-time for 6 years. I wanted to make sure I had both the opportunities to raise my child as well as keep my hand in that work. 3 years into that, I had our second child, and I took 9 months off that time. I had 2 of them to deal with. It took me longer to recover. And, but again, when I came back, I was still working part-time. And for my husband and I and our 2 children, it was a really good choice for our family to have that work-life balance, to be able to feel that when I went into work, I would be really work-focused. I would be working as efficiently as possible. I mean, the kids never crossed my mind. We have an excellent child educational center here, daycare center for babies through age 5. So I knew the children were very well taken care of. And I really enjoyed keeping my hand in at work. But then on the other hand, I had not just the 2 days on the weekend and the evenings to rush around and take care of the family, but also those other 2 days during the week. So that really made a great difference to me. And when I did come back after my 6 years of part-time work, my career had plateaued during that time, but I had not lost ground, and I was able to pick up and move forward from that point.
Now make a comment, because I did it totally differently. I have one son, and I took 2.5 weeks off when he was born. In fact, after 2.5 weeks, I was on a plane going to a meeting. But, you know, my son grew up perfectly fine. I never stopped working or worked part-time. I never gave up traveling. And in fact, it's a coincidence that Jean's youngest son and my son went through high school together, and they're now in college together. And
right, they both turned out great.
Great, that's right. So I think it's very much down to, you know, your choice, your personality, what you'd feel happiest doing. Because if I had stayed home for 6 months, I would have gone crazy.
I totally agree with you, Rosalie. I think that the overarching theme here is that when you come into that situation, ask your boss. Explore the opportunities. You know, what is available to me? What do I want to do with my family life? Ask your boss. Think of some creative opportunities. If you don't ask, you won't have the opportunities. And for me, it worked out great.
And most of all, know yourself. You know what's going to make you more balanced and happier.
And sane.
And sane, yeah. That's very important.
I have an interest in work-life balance for a totally different reason. I don't have any children, but I do have a husband who unfortunately took really ill one year. And I was, like many of us, probably are workaholics. We just work all the time. And I remember, especially when I start a new job, you tend to work a lot of hours. And this particular job I had, I would come in at 5:30 and stay until almost 10 at night, because I was a commuter, and I would wait till the traffic would die down before I'd leave. And on one occasion, he took really ill, and I couldn't get to him. And it was very difficult for me to feel comfortable knowing that I was not able to be more balanced at home. And so I made the decision at that time to commit to going home to dinner, you know, so many days a week. So 1 day a week, I make sure I'm home in time for dinner. And on weekends, you know, with us having so much access to information, especially checking your email and working at home all the time and working remotely, that's so easy for us. It's easy to consume yourself, especially when you have your type A personality. You tend to be a workaholic, to never take a break. And it will eventually take a whole toll on your own body as well. But what I try to do is not only commit to having a date night or a day where I go home for dinner, but also on weekends I make sure now that I check my messages periodically rather than all day. All day you could sit there and write messages and work on things, because there's always work to do. And you know, work is challenging, but it can be fun. But I do think pursuing some kind of balance is really important, whatever your situation is.
My story is a little bit different. Before I got married, I had a chance to go to Moscow for Mars. Back then it's called Mars 94, 96, and later on become, you know, Mars Express, and it's more European mission. That was a great experience for me by working, you know, with international partners to see how they build their spacecraft. It's very different than how U.S. you know, build a spacecraft. But that was probably my last international travel. As soon as we got married and have kids, we had 2 kids. Then there is some decision, you know, kind of made not just based on my decision. You kind of have to work with your partner. My husband also works at JPL, and he's in the programmatic side. And programmatic side means that he travels a lot. So when he decided to take that job, then I had to decide to say, okay, I cannot, you know, both of us traveling like crazy, and our 2 kids, what we're going to do. So we had decided to say, okay, you do the programmatic side, and I will do the line side, and that means, we do development internally, so I don't have to, travel that much. So this is some decision you kind of, make, not just by yourself, but you have to kind of do it together with your partner. And I agree with Meg that a lot of time you really do have to allocate time for yourself. Okay, I'm a human being. When I go home, I see my kids' piano not practiced, the homework not done, ages ago. And I'm just 10% of a tiger mom, but you just that 1 hour after the kids go to sleep, right? And for yourself, you don't have to say, oh, okay, let me just do more work. That 1 hour, you just want to sit on the sofa, turn on the TV, and enjoy. And I think that's very, very important. So it's the balance that you have to create. You have to love yourself in order to do good things for others.
So I think we have an audience that are all STEM students, and hopefully we've inspired you a little bit about different careers here at JPL and in the space. I'm going to sort of save room for some questions from you, but end with asking Diane, why space? Why should we be interested in exploring space? What are the mysteries and curiosities and big problems out there yet to solve?
Oh yeah, well I look at this group and I think of what you're going to be able to accomplish in the next few years, and it's going to be really exciting. I mean, the things that we're talking about doing, we're going to get samples back from Mars. We're going to be getting data streaming from some of the moons of the outer planets, whether it's Enceladus or Titan or Europa. And then, I don't know, I think one of the coolest things is we're going to be actually looking at atmospheres of Earth-like planets around other stars. I mean, the Kepler mission has just opened up this whole new world to us of how many planets might be out there that are just like our planet. And then speaking of our own planet, as I said, that's kind of my passion, but I think one of the most important things is in the very near future, if we stay on the trajectory we're going right now, we're going to be making incredible progress in understanding things like earthquakes, but also in the whole area of climate change. We're going to be able to really bring down our understanding of climate change to spatial and temporal scales that matter in terms of predicting natural hazards like floods and droughts, and then also deal with our resource issues, be able to manage our resources better, like water is one of the most critical. And so, I mean, there is just so much opportunity, so many exciting things to do. And it takes, as we've discussed here, it takes engineers, it takes physicists, it takes scientists, it takes chemists, all sorts of scientists. So it's really a lot of opportunities.
That's great. All right, I think at this point we'll open it up for Q&A if there's anybody out there with questions. I think we've got some mic runners. Don't be shy, very good.
Hi, I'm Sneha. I'm from University of Southern California, and I'm a computer science graduate student. Speaking about the opportunities, can you throw some light on opportunities for international students, or are there equal opportunities, or there are less opportunities, or how it is?
Well, I wasn't, international. I came here from abroad, so maybe I can talk about that. NASA has a program, a postdoctoral program, that is open to foreign students, to foreign postdocs, and that's how I got here, and that's how many of the foreign scientists in particular who are here actually have gotten here. So that's a really good opportunity. It's called the NASA postdoctoral program.
Yeah, we couldn't exist without a pretty large influx of international, employees. So it involves paperwork. There's no denying that. There's always paperwork. Yeah. But no, it's definitely, we talked about how important diversity is, and so that's an element of diversity that we really rely on.
And it's a great thing about being at JPL. It's like having a United Nations right here. We have people from all over the world.
Hi,
Hi, my name's Ann Emerson, and I'm here with a group of colleagues who actually do research in STEM education. And my question is just, what would you like to know more of, almost on a meta level, of how to best prepare students for some of these careers that you've talked about? You know, just like, what are some of your suggestions of things that we need to know more of to have more access to these great careers?
What level of education are you talking about? Are you talking about in elementary school?
All
or?
the way up, the whole spectrum.
All the way.
We have,
Okay.
I mean, all sorts of access.
Let me start with the older students. College students, the college curriculums tend to get a little too theoretical these days. They're much more, there's veering away from a little bit more of vocational, may not be quite the right way to describe it, but hands-on experience with what you're doing. They tend to teach the theory of something, but not how it actually shows up in practice. And because I'm an engineering manager, engineering is a lot of, you know the theory, but it doesn't always work that way. And you got to try it again and fix the problems and figure it out. And so kids coming out of college don't necessarily have all of that hands-on practical experience, and they don't have that kind of relevant work experience. And so, you know, trying to encourage programs like the APT Academic Part-Time Program or the co-op programs is one of the best things one of the best experiences that kids can get in college. Moving more into the high school age, again, work experience is important, but understanding the practicality of what they're learning, that physics isn't just what you learn in a textbook, that it applies in the real world, and trying to get them to ground that knowledge and that experience into how it can really help them on a day-to-day basis makes it more interesting for them and makes it more relevant as opposed to that thing we study in school. So that's from my perspective. I know there's other comments.
If I may add, I know some of the university, they establish, department for advisory board. They trying to draw different people from, companies and help them to build up the curriculums. Okay, I believe Cal Poly Pomona in the computer science department, they have something like that because I was the member. So with that kind of exchange, the school will know what is the demand. What is required, and it can help the school to develop a better curriculum. And just like what Kendra has said, it's really focuses more in the hands-on experience and also teaming too, right? Because a lot of time your project that you have gotten is all individual, but a lot of time the challenge is really working with the team members and how to resolve the problem together. So throughout that kind of program and setup, I think it would be very helpful for you guys.
What about in the research area?
Yeah, I find, especially as a planetary scientist, I don't like any of the sort of third grade. As soon as kids start having a vocabulary large enough, I don't like any of the books I see. And I think kids are not afraid of large vocabulary. A kid who can memorize all the dinosaurs and tell you all the aspects of what every single reptile was like, they can also learn about the Earth's atmosphere and all the layers, the troposphere, the stratosphere, magnetospheric physics. I mean, all of these are things we shouldn't be afraid to dive in a creative way illustrate. And I also would like to see more multicultural material. I'd like to see, African American kids in science shown that way in textbooks and so forth.
Hi, my name is Shrina, and I'm from the University of California, Riverside, and I'm a third-year mechanical engineer. I know earlier at the beginning of the talk you guys mentioned that you definitely recommend going into higher education. And my question was, I've been to a couple other panels, and they kind of said how going into higher education in the sciences and engineering kind of sometimes to employers made them seem like overqualified or too specified. So I guess you're shaking your head no. Yeah. Okay. So I guess I just wanted to know what your take on that was, if to maybe go into the engineering and sciences or like go into maybe a business administration degree of some sort. So I guess between the two different fields, what your recommendation was. And also part two, is it hard to go back into school if you perhaps take a break? A couple of you said that you went and you worked for a bit and then went back to school. So was it difficult making that transition, or was it just kind of, you just got right back into it?
I guess because I was shaking my head, I guess I'll answer that question. When you come out of undergraduate with an engineering degree, you've learned a lot, you're very capable, but there is a huge amount of information, knowledge, and experience that you haven't even tapped into. And I don't think a master's or a PhD makes you overqualified for anything. I think it just makes you maybe more focused, maybe smarter at a different level of the field that you're studying. A PhD, people tend to associate with science and research. Some of our best engineers, some of our best managers, some of our best leaders in the engineering field are folks that you would never know have a PhD. They don't go by doctor all the time. They don't, put it on their, their business card or things like that. But they've learned a skill through the graduate program that they're in of analytical thinking, of verifying assumptions and things like that. And those are general skills that are applicable in a lot of places, whether you're actually furthering along the path of what you studied in your PhD program or you're doing something completely different. And so, no, masters and PhDs do not make you overqualified in the engineering field. There's still a lot out there. Is it hard to go back? I went back after 2 years, and yes, you do get accustomed to a salary and income. Leaving and putting your pencil down at 5 at the end of the day, which when I was an undergraduate student, you were pretty much working 20 out of 24 hours a day, studying over breakfast and everything like that. You don't have to do that in the work world. You can, but you don't have to. So if you wait more than somewhere between 2 to 5 years, yeah, it's probably pretty difficult to go back. It was a transition, but it's doable.
And I found a lot of students who was APT here and decided to go back to for master degree after they've completed their bachelor. They usually work for a year or two, then they go back. One thing I thought was really useful for most of the students was that when they decide to do the final project, if they can pick something is related to what they're currently working on, okay, it tends to be more interesting and seems more motivated. So that's one thing I think is very helpful. You mentioned about business administration degree, and I think I'm just going to give you a pointer here. It really depends on if you feel there's a need during your career. A degree, whatever the level, is providing you a tool. And it's really up to you how you're going to apply it, at workplace. So that's my point.
I think we have time for one more question, and I think we've already identified who gets it. But we will be around for a little bit afterwards, and we'll be having yet one more little segment here before we do that.
Hi, my name is Michelle Sestado, and I'm from Mount San Antonio College, and I'm a chemical engineer. My question is, what advice would you give to a very curious student such as me? An example is that I'm working in a chemistry lab with magnesium oxide aerogels, but yet I'm also the captain of one of the 2 robotics team at my school, but yet I'm also very interested in astrophysics. So I'm kind of all over the place. And what advice would you give to a student like me who is just, everything is like appealing, and I'm very much into science and math, so everything interests me, so yeah.
One answer. Who wants to take it?
I'll take that. It's, because I was interested in a lot of things during most of my degree. I was interested in astrophysics. In fact, I was going to do astrophysics, and then I found something else I had a real passion for, that was, planetary geology. And I think the best way is do a master's or a PhD. Try to find that one area that really you're passionate about, and it doesn't mean that at a future time you cannot change. In fact, people have made amazing career changes, particularly from a first degree. One of our very best scientists here, who unfortunately has passed away, he started out with a degree in French and art. And he said he got interested in ceramics, and and that's what kind of led him into the science later on. And he did a master's and then a PhD. So all I can say is that at this stage, a lot of things will be appealing, and it doesn't mean that you're only ever going to like one thing, but find something that you can actually feel that calling or that passion for, and follow it.
I'd like to thank the panelists, and I'd like to have you give them a big round of applause. I think some of them.
At this stage, a lot of things will be appealing, and it doesn't mean that you're only ever going to like one thing, but find something that you can actually feel that calling or that passion for, and follow it.
I'd like to thank the panelists, and I'd like to have you give them a big round of applause. I think some of them will be here for a little while. We can't let this great pipeline of talent leave without giving you a little pitch about job opportunities and what we do here in terms of careers. So I'm going to invite Parvin Kasai to come up. She's going to do a little presentation on our education office, and I'll sort of end with a pitch for the employment opportunities at JPL.
Thank you. Good morning, or good afternoon, rather. The conversation we just had, the questions that you asked, are a great segue to this next section. We just would like to take a few minutes to extend an invitation to all of you, to the students in our audience and the young researchers, to join JPL and NASA through some of our internship and fellowship opportunities. You just heard many wonderful inspirational stories of careers and all the ups and downs and challenges and successes. And you also heard that it wasn't always easy to get where these accomplished scientists and engineers are. You heard Dr. Alachi this morning talk about the group of women who were here at JPL. Next slide, please. Who were here in 1940s and 50s. These were women with some college education for that time. They had at least 2 years of mathematics behind them, and they were trained to work on JPL's IBM machines. They were doing theoretical calculations, and they were doing experimental data reductions. And for that time, and given that they were women, they were quite advanced. But as Dr. Alachi said, they were doing very narrow technical work here at JPL. So this morning demonstrated that women have come a long ways in what we call STEM fields, science, technology, engineering, and mathematics. But if you look at the entire nation, you'll see that the great gains are not really still on par with what needs to be achieved. Next slide, please. This is data from National Science Foundation, and this was referred to earlier again this morning. If you look at the number of women, if you add up all the little slivers there and add up the number of women, it adds up to about 26% of the STEM workforce in this country. As opposed to 74% for our male counterparts. And if you look at the ethnic breakdown, you'll see that it is even, that the challenge there is even greater to overcome for some ethnic groups. So there is a lot to be done, and we are happy to say that at JPL we are taking steps to remedy this. Next slide, please. We have a number of internship and fellowship programs at JPL, along with HR and with the Office of Chief Scientist, the Education Office here at JPL. We all bring over about hundreds of students, well over 500 students every year. And if you add other participants in our internship and fellowship programs, we have over 700 people every year that come to JPL for opportunities to do research and development work. At JPL, we have now, I'm happy to report that in 2011, our numbers showed that we have 40% women participating in our internship program. So we are well above the national average. But we're not there yet, and that's why this pitch to you. We would love to have you join us. Even if right now you're undecided about your careers, even if you're undecided about your majors, but you do have the passion and the vision and at least some set of skills that you can be comfortable with to start, we would love to give you the opportunity to explore working for JPL and working for NASA. Next slide. The same thing for our postdoctoral programs. If you are graduating, if you are thinking of doing a postdoctoral program, JPL offers several postdoctoral programs, and our numbers there, as you see, 25%, a quarter, at least a good quarter of our postdoctoral offerings are for women. And again, this is, if not better than the national average, it is at least on par with the national average for postdoctorals in STEM fields. So we encourage you to think about the opportunity again as you are moving towards graduation. And to help you do that, on next slide, please. We're inviting you. See how cool it looks? We have information on these two websites and the ones that that Cosette will share with you next. The first one on top is the JPL Education Gateway, and there is an icon. Oh, no, wait a second. No, the first one is the postdoc, excuse me. So on that website, you will see the number of postdoctoral programs with information and requirements for participating in each. JPL truly values its postdoctoral fellows. It's a very supportive environment, and they are a great part of the research community here at JPL. That's the website that will give you further information, and below that is the Education Gateway. On that website, if you click on Internships and Fellowships, a menu of programs opens up, and you will see that we still have many opportunities open for participation. I talked to some of you during the break. I encourage you to look. I'd like to extend that offer to the rest of you. There are many, many opportunities open still for summer, and we also have year-round programs for those of you who may be going to school and going to school part-time and looking for opportunities to learn about a professional environment and explore a career. If you are within 50 miles radius of JPL, we have year-round programs that we would, again, like to see you participate. And then we also obviously have summer programs. These are all paid internships. So I see a few smiles. These are paid internships, and again, you get to do real work here. You get to do real research. It's not go for a job. You're not running errands or making coffee. You may be doing those things, but you do it in a way that a professional colleague would do, not as a part of We all do that. Yeah, we all do that. But when you're an intern, that's not a good sign. You think, I'm being given a go for work. But my point here is that these are real meaningful opportunities for participation. And JPL has a very supportive environment for interns. We have a great infrastructure that allows students, no matter which program they come through, to work together and to work with the entire community. I'll be here after the program. My colleagues also will be here. I think I see some of them in the audience, and we'll be happy to answer any questions that you have. But please take those down and visit us.
And then the final slide, if you'll put that one up. Parvin talked about every summer we have about 500 students here at all different levels. We also recruit on at the colleges and universities and much of the funding for Parvin's programs come out of the NASA programs. Ours come out of JPL as well. And through those combined programs is where we bring in, all the students. We hire undergraduate, graduate, and doctoral students. Our workforce at JPL, we talk about being a third PhDs, a third masters, and a third undergrad, so we kind of recruit the full gamut. You can see the kind of opportunities that we look for, and we've been historically very committed. We will hire about a little less than 150, between 125 and 140 students per year, graduating students a year. So we have 5 generations of people working in the workplace here at JPL, and we're quite proud of it. We are very respectful of the people who started the space program, and we're very respectful of the people who come out with fresh ideas on how to do things. So we'd welcome you, and again, we're here. And thank you for coming. It's great to see all your faces.
So we have come to the end of our journey this morning. Let me take a moment now to acknowledge all the schools that have sent representatives here. We are really, really grateful to you. We have seen your excitement. We are just as excited as you are to see you be part of our family today. And it was a great pleasure. I think a lot has been said about careers, about our desire to see you join our family. I think I just want to quickly conclude with a movie line. I do feel that this is the beginning of a beautiful friendship. Thank you again.